recording. Okay. So, Nathan, are you there? And
Nathan is awake.
how climatic. But anyway.
Yes,
uh,
that could be. Oh man.
A lot of noise here. Okay, that's fine. Okay, so we have two options today again, as always. We have the actually three options, right? The first one is to make sure that parsing is working. All the things are working, like all the
No,
parsing
thank you.
crap is working.
No,
Making
thank you.
tests is the second option.
No, thank you as well.
And uh, do what Nathan said about starting doing type operators.
Yeah, that's the only option left, I guess.
That's
My
the.
enthusiasm, I think, is awesome right now.
Oh man. So, the only person that has
So,
an idea of how to do type operators is Nathan, as far as I can tell.
so we're talking about like type constructors, right?
I will send the link. Okay, there's a link.
All right.
Uh,
Let's wait for Nathan's magic link.
yeah, link is gonna be there. It's gonna be fun. Okay,
I'm
so
afraid of opening this chat while you are recording, to be honest, because I don't know what is in there. Just sitting here. I don't know, man. We send a lot of bullshit. Just sitting here on
Oh my god.
Spatula.
Okay. Oh, something that you can try already, which is actually something that we can do that is not it's not going to require so much time. Okay, he sent the link. You can open the chat. There's nothing too bad there.
Okay. I hope. Dude, what the heck? Oh man. So much fun. Alright, let's see. Oh, he already implemented this. Let's just copy and paste. So
Let's try to
let's
understand it
see.
first. So we have something called a type kind.
Yeah, so star and arrows. Oh, I did this shit, man.
So you do know type operators then. Great.
Yeah, I did this. But I was doing this in F star.
Okay, the expression is the same.
Yes, we just gotta add here, I guess.
Oh, you need to add the for
Yes.
all also.
Let me see. Yeah, here.
Oh my god, everything's gonna break, man.
Yeah, and this didn't.
No, wait, let's
And
do
by the
the
way,
following.
this did not exist, so we have to add this.
Oh yeah, in abstraction also.
Yes.
What you were saying, Nata?
What about we do the following? Uh,
Ooh.
uh, I talk a little bit about the thing, and then we like go implement it piece by piece. And
I like
if
that.
we forget about
Yeah.
something, we take a look on the code, right?
Yeah, I like that. I like that. You're gonna exercise if you really know what you did.
Yeah.
Okay, so can you start from the beginning then?
Yeah. So okay, like picking up from the system F stuff. So lambda calculus, you have terms, two terms. System F, you gain types, two terms, right?
Yes.
And then we have the nice one. With System F omega, we have types, two
The
types.
names are great.
Right?
It's like I don't know, sweet Gundam, you know.
No, I thought about Power Rangers, but Gundam is also the same thing.
But yeah, and yeah, that's really funny because uh, in the same way that we have terms to terms in lambda calculus, in our case, typed lambda calculus, right? This simply typed.
Yeah.
In the same way that we have terms to terms, implementing types to types is basically the same thing, man.
Okay, so type to types is the type operators, right?
Yeah, it's type operators.
Mm-hmm.
But that's the thing. The way you implement lambda calculus with abstraction, application, variable, beta reduction, renaming, and stuff, you will do the same thing, but on types.
Okay. Okay, that makes sense.
Okay, now doing a parallel with things that we actually use in our language, right? Okay, that feature in our language, they are the type constructors, right?
Yeah.
So we can create a type and we can abstract over a specific component, right?
Yes.
Uh, uh, yeah, I don't think there is much more about than that, I guess. Yeah, the rest we will see.
Okay.
Because it's like more general what we will implement, right?
Mhm.
But we kind of may want to limit that for a language because, well, it has better usability if it's not that general, I guess.
Okay.
Okay, so
I think the first thing
uh,
is to create the data type kind, right?
Yeah,
yeah,
we need a context as well for it, right?
let's go to RAST first.
Okay. Go to. Can you go
Yeah,
there, Magenta?
let me comment this. So this is already no, this is not it. Types, I think.
Yeah.
Yes.
So can you scroll down a little bit? Yeah. Okay. So
The,
where in the AST, Magenta?
So, okay, RAST, we have the expressions and the type so far,
Yeah.
right? And in the same way that we have an abstraction, an application, and a variable in our expressions, we will have those, but in our types. So we already have the variable, right?
Yeah. Type variable. Yeah.
Because, yeah, we are using for the for all stuff.
Yeah.
But now we are also going to have an abstraction there and application there, right?
Oh. Okay. So it's gonna be T abstraction and T application, I guess.
yeah.
Yes.
So what are those two? What these two things ask for? What do we need to make them?
Okay, first of all, the application, right?
Yeah.
It's the same thing as the expression, but instead of expression, it's a type. So type
Type
to
to type.
type.
Mhm.
Type to type. That makes sense.
Can see both there.
Yeah. So it's type to type there. Okay, makes sense. And what about the
Oops.
type abstraction? Is
Yeah.
also a direct parallel.
It's a direct parallel. So give it a
Even the
try.
return.
Give it a try.
Okay. So it's gonna be uh, is a type to maybe type maybe. What
No, no,
comes
no,
in the
wait,
place of
wait, no,
text?
No,
wait.
no, 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 no.
Take a look on abstraction there.
Okay. Abstraction takes a text, which is the name of the argument, the type of it.
Forget the maybe type also because, well,
Yeah.
that's just something.
That's huh?
Hello? Can you
Okay,
hear me?
now I
Hello.
can hear you.
Oh, okay. So, like, take a look on e abstraction or on our expressions, right?
Mm-hmm.
So, take a look at it, but forget about the maybe type because that's there just because, right?
Just cause lows. Okay. So you can. I think we can get away without the maybe type, because this is the return type, right? And I don't think for type operators we should have that. It's kind of unnatural for me. I don't know about you guys.
Gone.
Okay. But instead of an expression, we have a type also.
Yes.
So the
Oh,
question is,
damn.
what is the text? That's my
So,
question.
let me talk about e abstraction, right?
Yeah.
So, we have a name for a placeholder,
Yes.
right? Something that describes our input in some manner, right? And we have a body that is like what we are manipulating, right?
Yeah.
What we are abstracting over. So the body, let's call it, is in a specific level, right? Like some, it's, how can I say? I cannot use the word type or kind because they are involved in the domain.
Sort. Let's say sort.
Sort.
Sort,
Okay.
sort, sort is the accurate one. They even use on Wikipedia and such. So okay, we have
Of
one
course they
sort
do,
of
man.
thing.
Type and kind they can't use.
So okay, we have one sort of thing that is on the body. That's the domain of the things we are manipulating, right? Uh, and since the input and the output they are in the same sort, then we are classifying what is like the sort of the input, right?
Yes.
So in the case of e abstraction, we have the placeholder that we are going to use inside the body. We have the body that it has the sort expression, right? And what is the other sort that describes the expression? So we can put that on like guarding our input.
I don't know if I get the question.
Okay, let me rephrase it. Oh, we have input and output. They are
Yes.
both terms, right? They are both
Yes.
expressions, right?
Yes.
But we need to restrain what we are receiving as an expression, right? That's the whole point about type systems and such, right? We are
Okay, go.
constraining stuff. So we have something to describe that constraint, right? Regarding the input of that abstraction. What is that in the case of our E abstraction?
It is to describe the input, you say?
Yes.
It is the type.
Yes, exactly. So doing our parallel, we have a name for the part being abstracted, the placeholder. We have the body, that in this case is the sort of type, and then we have
Yes.
something to describe, right?
Yeah.
Exactly.
Oh, okay.
You see the parallel?
Yeah, it's literally
One
going up a
sort,
notch.
right?
Going up a notch.
Yep.
Okay.
So
So,
there is also a change on here, right?
On the T for all.
Yes.
how is
I think
that?
we also need a kind on the T for all, don't we?
Oh, yeah, we
Where
do.
is it? So it's a text type. We need the kind here.
Mhm.
Is that it?
Lemos.
Okay, go, Nathan.
Uh, like
Thinking.
about the higher kind of stuff, right?
Mm-hmm.
So, places where you would receive a type, right?
Yeah.
That would be like the for all or the type abstraction. They would be limited at only receiving a simple kind, right? Like the kind star. And that's the higher kind of stuff. You can receive like arbitrary ones, right?
How do I? Okay, it's just making parameters, right? So a kind takes
Can you
another
repeat that,
kind.
Nathan? I had a problem here. We'll continue.
Yeah. So, okay, let Magenta finish this, then we can like see better, right? So Magenta did the kinds there, and we have two possible kinds, right? Is either a star, and what the fuck is a star, man? A star, take a look on that.
Yeah.
It's the kind
Okay.
that describes a type
Yes.
that describes an expression,
Yes. Yes. I agree
right?
with that.
But then you could ask me, oh, but that's any kind, right? Any kind describes a type that describes an expression. Not really.
Yeah, not really.
Okay, so you got it, right? Like I can have the kind for a type, and this type doesn't describe any expression. What would be one of those cases?
Uh, the question is when the type does not describe an expression, right?
Yes.
Maybe.
Yeah, maybe, right? Because maybe doesn't say shit. Like,
Wait, but I have a question though. Why are we limiting ourselves to just a kind to kind? Because as far as I can tell, the star k is the base case of the recursive type, and we have an arrow which has a kind and a kind. Why are you using the tuple as the abstraction?
I
Oh,
didn't
it
get
could
it.
be just this, right?
Yeah,
Oh, okay. You mean implementation wise?
yeah.
Yeah, it's just I'm a tuple maniac. I just do this.
Okay,
But
so
what is this generic for? I
this
don't
is for
remember this.
allowing us to make arbitrarily, like to make the compiler generate tests for us.
Oh, but what's that happening?
Not at the moment. I will make that happen later.
All right.
Man, imagine allowing the GHC making arbitrary programs for us. That would be great.
Well, there are gonna be shitty ones, but okay.
And you know
So
what's worse? Because of the halting problem, we can say to GHC, "Oh, make a problem that halt, please."
yes, it's gonna be any garbage, literally. So okay. So here we gotta do kind.
Yeah, now we need to fix everything else because
Actually,
everything
let
is
me not
broken.
add it here. Let's go one by one.
Yeah,
I
one
don't
by one.
remember. Okay, so the type substitution will change.
No, wait. Let's just add it there. So like we stop the errors, right? And then we like go piece by piece.
No, I think that's bad
Yeah,
because
but
we're gonna
we're
forget a
gonna
place.
miss, man. Yes.
We're gonna
How
forget
is that?
Yeah, we're
Oh,
gonna
because
like
okay.
forget where.
yeah. Okay, so the first thing is equality for alls, right? Which is the T
But
for all
yeah,
info equality.
okay here,
Yeah.
right.
So we have now a kind 1 and a kind 2 that we need to work with.
Okay, see. Kind 1, kind
So
2.
how can we compare for alls with now that we have the information of kinds, Nathan?
That's easy, right? You have one more thing there, so you also compare, right?
So this, how do we compare in Haskell?
No, I
This?
think it's the no, it is like this, Magetta, but I think that this is the then and the else branches that we need to pay attention to, right, Nathan?
Oh, okay, I see. Here,
So it's
right?
gonna be
If
type
they're
1,
both different.
yes, and
And
the kind
kind
1 with
1
kind equals to kind 2.
is okay.
Then, but
Okay,
now we need
and
the
here's
else.
tricky because we need to send to the
Wait,
substitution as
wait.
well.
We could do the following, man. We can do the kind first because I think. Uh, yeah. Because like if the kind it's not equal, then you can already discard it, right?
If the kind is not
Yeah,
equal, you
I
can
get
already
it.
discard it.
You don't need to do like anything more, right?
That's
Wait.
true.
Wait, but
If
oh, to do this thing first. That's what we mean.
that's ugly, but let's see. So,
Yeah,
oh
do a
man,
tab.
like really, like that thing in Erlang was very useful. Like the same thing.
Yeah.
Okay, but
Okay, so
do
if
tab on the line, the then and the else. Yeah, these ones.
Oh, by the way, I was thinking about that, Mageta. I think that maybe it's because when they are doing that, shouldn't. I'm not sure, but I was thinking that was something regarding, oh, you have to say that both are equal and you could not check that. But I'm not sure if you would need to check that at compile time. But yeah, maybe there is a reason on why they don't do that in other languages.
Okay, so if the kinds are equal, we do that. What if they are not equal?
Well, then they are not equal, right?
yeah, so it's all.
Oh,
So
wait.
these expressions are all booleans, right? So it's
Yeah,
just
else false.
false.
Capital F.
Okay.
Okay, but now we need to change type substitution, I guess. Is that correct, Nathan?
Yes, I think so.
Uh,
Where is it? What?
wait.
Oh, because it broke here.
We check the kind. If they are not equal, they are
Yeah.
not equal. If they are, then
I saw that in
uh,
your code you have something called kind equality,
yeah.
And
which is I guess the updated version of equality considering the omega now. And I kind of don't like that. Everything needs to understand kinds at this moment. I thought it was
No,
kind
man,
of an add-on.
man. That's just the thing that you derive. That's kind to equal to Boolean, right?
Kind to kind. What? Sorry?
That's just the equal between kinds. Like it doesn't involve like anything more.
Oh, you can derive then.
Yeah.
Great. Okay, let's do that.
okay.
No, but you okay? So just derive that, Magita. Go to the code and add deriving in the list of things that we are deriving, and then
Here's
comma
the
equal
thing. Here's the thing, man.
data kind right there. Your
Oh,
your, your
here.
cursor is
Okay.
just add equal. No, no, no,
Deriving.
no, 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 equal. We already
Yeah,
have
because
equal.
you said deriving.
Yeah.
Oh,
Okay.
yeah. Okay.
Okay. So what
Oh, yes.
about
We
updating type
implement
substitution?
substitution.
As far I guess type substitution needs an update also.
I don't know.
You don't know. Okay.
Awesome. So
So
let's
let's
see.
think about
So
that. So
I think we can handle. Well, let's start. Let's see. We're not. Let's start with the for all. Like we
yeah.
have the kind now.
Yeah, we have the kind there.
which is this is like the dude. Okay, kind. Let me do this. Ah, no, never mind.
Yeah.
Okay,
So
and with the kind, we gotta check. Oh man, I don't like this line.
you can break
Yeah,
it. I think you can break.
I don't think we need kinds there, because what we want is inside of this type, all of those
Yeah.
type variables will become
No,
something else. Like,
we want to construct the next, right?
Yeah, we
In
need to
this case,
construct
you
the
do.
next, Nathan.
huh?
Okay, no, you're already getting here, right? This info,
Uh,
like just propagating, so we don't even need this, I guess.
yeah, but no, we do need because
Oh,
on the
for the other
otherwise
one.
case we need to.
Oh
Yeah, that's
yeah, you
true.
don't need to just pass through, right?
Yeah.
Yeah, here. Okay. So
Okay.
the other case we need to do is the abstraction and the application.
Yeah,
Yeah.
I guess they are literally the same, man, as like for all and arrow.
For
For
all and
all
arrow.
in arrow. Oh, the most complicated ones you mean?
Let's
Not
do it
really.
here.
Like, do the type application for you to see.
Application.
So you have I don't know.
I don't remember the parameters, but I think it was
It's
type.
just two
Like,
types.
Oh
The
no,
type
it's just two
application,
types.
just two
Yes.
types.
So it's the abstraction
Yeah,
tie
and the
and
body.
oh shit.
arg tie.
Oh shit.
Arrow to the
Do you
right.
want me to do .NET, please? Abstraction
.NET. Oh
argument
shit.
type.
That's fine. That's not the worst. Okay, so arrow to the right. Yeah. Now we need to think about that. So
Oh, we
how do
just
we?
build another one. Yeah, we just build another one with the substitution, right? Like T application again with the type substitution.
Oh, I see. I see. But wait, why do we need? I think I need to think about that. What is a substitution on type applications?
Let me just do this. What? Oh no, this is right. We need
Yeah, it's
to
gonna be
annotate stuff, right?
placeholder.
Yeah, so it's gonna be the. Wait, I'm confused. Placeholder. Okay, this
Type
thing here.
prime, which is the one that we want to swap.
Dude, my placeholder. Why is it not? Oh, capital letter.
Why
Type
is that
Uh,
prime.
type? Hey, why is it type prime in type substitution? Is it because it's a legal keyword?
The word
yeah, I
type, you
think
mean?
type. Yes.
Oh, I see.
Yeah. And then we need abstraction type and argument type below.
Mm-hmm.
Abstraction type. Oh, Magetta, can you give me an example of a type application? Just me to understand, to see if I'm understanding things
Let me
correctly.
see. Let me just pass this
Yeah, argument type.
argument type. So let me think of an application.
Or you, Nathan, you can also provide an example.
Yeah, I will type on it.
Okay, thanks.
I think it could be application.
So suppose that's your target, right? And you want to substitute like I forgot what is the name of this letter.
Okay,
X and
that's
Y.
Yeah, Y for something.
what the heck? How did you forget X and Y, Nathan?
Okay, continue, Nathan.
So yeah,
You want to do what, sorry?
no, that's an application. Do you agree?
Yes.
Mm-hmm.
So I want to substitute that application, the Y, for something else.
The Y
So
with something
Yeah.
else.
so how would you do it?
Oh, every place that we have an abstraction, we're using the Y, you replace, and everything in the body replace. Yeah, so now I got it.
Mm-hmm.
Okay, so let's do the T abstraction, I guess.
Yeah.
So
So
it's just
just one detail. You said the body, right? But not necessarily. We mean we mean the abstraction, but not necessarily the abstraction will substitute in the body, right?
I mean, what you're gonna apply
uh,
substitution on the Y's that are on the left part of the application and on the right part of the application. That's what I meant.
Yes.
yeah.
Yes.
Okay. So
Okay,
next one is
I think
T
it's
abstraction.
T abstraction.
Yeah.
So this will be nasty. I think.
No. Like
Okay, so we have a name like a label, So label,
Okay, I don't recall the stuff. So
and
what
then we
was
have
it?
a kind and then a type.
Kind and a type. Okay.
So kind
Kind.
and type prime. No, not type prime. Type prime prime. We need
Oh,
two primes.
there are two of them.
Yeah,
Okay.
because okay.
Okay.
Then we need to think.
So
Yeah.
we need to check if we already have this thing.
Wait.
Let me think.
I think that we just need to call it recursively,
Mm,
ignoring and passing on the type and the kind and the label, and just swapping the type two primes.
No, wait. We have to check stuff.
What do you need to check, Nathan?
oh, if
So Magenta
okay.
was on the right track.
Okay.
I mean, we need to
Magenta.
check if this matches the type we're substituting. Is that it?
No. Like this abstracting over something, right? So we need to consider the shadowing thing first. So if the
Okay.
label in which we are abstracting over is the one we are looking for as a placeholder, then we don't really do something, right?
Okay, so if
Okay.
placeholder is different than label, we do
No,
something.
if
Can
it's
we make
equal,
the
yeah.
Haskell? How do we make the like this, right? The Haskell guard
Yeah,
thingy.
you do the Haskell guard.
So we can use this.
Yeah.
How is that doing that? Let's check. Uh, here. Where is it?
Type abstraction.
So let's see. So you take this thing, which is the parameter name, and you don't care. You just boom, and
You
then you
check if it
see
is the type underscore.
parameter name with from. What is from?
From is the placeholder in our case.
Placeholder.
Yeah. So
Okay.
okay. So if they are
With the
equal,
parameter name. Otherwise, okay, you just propagate this thing.
yes.
Yeah, so you just check if the thing is being shadowing or not, and then you
What is the
just pass.
placeholder in the middle of the braces doing after parameter name?
What is the placeholder in the middle of the thing?
Yeah, the
Which one?
underscore in the middle
This?
of no the other one on the left.
This?
On the left.
The left? Oh, this.
Yes. Yeah, on the right
On the
one.
left, and I go to the right.
The right one inside that.
This?
Yeah.
Just ignoring.
So you have parameter name and you have you have
Yeah, it
other two
just needs
stuff.
this, right, to compare.
Wait,
It's just saying I'm not getting all the fields from this record, so I'm ignoring.
type underscore is what in this case? You are renaming it as
It's
what?
this thing. It's this the entire thing it
Oh,
takes.
okay.
So it's
But
the
dude, like,
entire thing.
can you do this in
Yeah,
Okama?
that's something that I'm very. You have three things inside it, but you could have only one underscore.
Yeah, I
Wait,
can't do this in F sharp.
wait,
Cool.
Like, there are three things. I could only do this and then this.
man, like a record is not position dependent, right?
It is.
So it is not. It's the whole point
I
about
can't even
record.
I can't even deconstruct like this,
No,
as
no,
far
no,
as I
no.
remember.
Wait,
Oh no
wait,
no no!
wait.
It is not position dependent if you use the same name as the name of the field.
Huh?
It is not position
No,
dependent.
no, no, no.
I'm
That has
increasing.
nothing to do with pulling. Man,
No,
tuples,
I'm not accepting this anymore.
I'm not
tuples.
accepting.
Hey,
Where's my
listen up. Like tuples versus records. Tuple, the position matters and they don't have names. Records, the position don't matter and they have names. So,
Yeah, you didn't. I think didn't deny what I said. I still think it is what I
okay,
said. Then
what is your thing?
the thing is that if you are as accessing something inside a record with the name of the field as the name of the as the label of the thing that you
Okay.
are manipulating, then
okay?
it's not position dependent. Then it's not. But
Yeah, I think you are. Okay, go on.
but if you want to use another label in the record, but getting another field, then I think it's position dependent.
Yeah, it doesn't matter. So doesn't matter the name that it is on the type and the name that you want to use. What I mean by position is that you can literally switch the order in which you are matching. See?
Switch the
So
order. Yeah.
yeah, the thing regarding using the same name for the binding as the name that is on the field, like in the type, that's like pruning. That's just syntax sugar. Has nothing to do with the nature of a record.
I think we're gonna have to dig deeper on this later because I'm not as like mesmerized as Magetas because he's literally doing it freestyle.
Yeah,
I
but a thing to notice about the underscore numbers, it's because if I have a record, and then he will give me a warning if I'm not getting all the fields right.
Yeah.
That's kind of nice because if I'm having everything and then I change the record later, he will tell me, right? If I don't have the underscore there, he will tell me, oh, your thing changed. Then I will give you a warning
It
because
is
now you are
five
not
A's,
getting
Mageta,
that.
not four.
5 A's. Oh, yes.
Why so much haste, man?
Yeah.
Because I was like shouting, ah. Okay.
Anyway, go on, Nathan. I just want to understand what exactly type underscore in that thing is because it is a record that contains
No,
what?
type underscore.
Yeah.
It's the
Ha!
whole record. It's the same thing as the at
Look.
in Haskell.
Yeah. So it doesn't work in F sharp. Cool.
Uh,
This also doesn't work in F sharp.
I remember that I cannot do this in F sharp. I
yeah, that's
tried this.
bad. So you don't have the warning.
Yeah. Garbage. Wait, or is it just a comma? Wait. In Okama you do have the semicolon, right?
Yeah. Try the comma then.
I don't think
I
it's a
don't think it's
comma.
a common
Yeah,
record.
if it is, then it would be pretty cursed. What if with the name, maybe? Let's see. A, B. Oh, that would be very cursed. Oh, it is! That would
It's
be very cursed, and it works.
no, that's totally a different thing, man. Your three codes that you did there with one underscore, two underscore, and this one that they are named, they are three different things, man.
No, but the
Like,
other ones
What?
don't work.
Yeah, the other ones, they're not
no, yeah,
acceptable.
to start, like the second one doesn't even make sense.
Yes, I know.
The first one, they just don't have it, like not to
Yes,
camera, right?
but
And the
these you
third
do.
one, it's like you're just not binding it, right?
Yeah. Yeah, that's pretty. Yeah, I'm okay with that. I like having nulls
But I mean, you
all the
can't do
time.
the do your first example, but delete the underscore.
Oh, I already
Nah, it's done.
closed.
Oh,
But
okay.
anyway,
Okay, I want to understand something though. Go back to Nathan's code, Mageta, please.
Man, the
okay.
Okay, so
S,
what is the type? What is the type underscore, Nathan? What is
the
that?
Visinfo.
S is the same thing as the at in Haskell.
It's like Visinfo at.
Yeah.
No. That I understand, but uh, it is. Let me try to explain, and then you can
Wait, this is my
confirm.
data between the record and the label T abstraction, right?
Okay, but let me try to explain to see if I get it. So type underscore would be a record in which it has three things: parameter name, parameter kind, and body, in which the parameter name is equal to from. Is that correct?
Da, 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 da. Uh,
Nathan?
kind of. If you mean after the arrow, you are right because of the guard, right? But that's a bad way to think in it because inside the guard, it would not necessarily be,
I
right?
don't understand any other way of explaining. Can you try to explain another way?
Uh, Man, type, it's the thing we are matching on, right? So if you go up there, go on the match with part.
On
Match
where?
with.
Yeah, you see this type there? It's the same one. So it's
Wait.
everything at the left of S.
Wait.
Everything to the left of S.
I am very confused. What is type underscore on line 130? That's what I.
130?
Yeah. Type underscore. You're saying parameter name, and then you were like ignoring everything else as type
Okay.
underscore. That's what I want
This
to understand.
type is the abstraction, and that's it. It has a record.
Oh, so you're using shadowing on the names.
Yeah, shadowing on the like parameter there, right?
That is a very no, that's terrible practice, man. But okay, I
No, no,
understand.
no, 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 no. That's the opposite.
It's
Why am I
terrible. The two
not?
names, two
No, no,
things. One
That's
name,
the
two
opposite.
things.
It's
no,
amazing
no,
because it made the code. That's what he should say.
no, not
Just to
really. It's
punish you.
because take a look. If you have a really large like pattern match, and then you are just using type, and it is not on those bindings of your pattern match, you have to look up there to see what the fuck is type. But if I'm looking there, I only have to look at the bindings there. I'm not using like anything external, right?
Yeah, but you have one name for two different, completely different meanings, man.
What do you mean they are the same
But
thing,
that's what I
literally?
asked. I asked this in the beginning. That was one of my first questions. Is type underscore on line 130 different than the one that you're doing the match?
I didn't heard that for sure, but yeah, they are.
They are different.
No, no, they are not.
Oh, they are the same.
Yeah.
Everybody's confused here.
Uh,
It's not the same thing as Haskell that we are doing with info, man.
I'm still not understanding Nathan's code, but we can continue. So what we are doing, Mageta?
So it's the second case, which I didn't check here yet, but it's just this. So we pick the label, the name, the label, which is the placeholder, the kind, we propagate. Oops, is that right? Oh yes,
Wait.
it is. I'm looking from here.
You need to add
And
the
then
otherwise though. On line one up.
just one thing, like, okay, I see.
Okay.
This, right?
Yeah.
Okay. And then here we just substitute. I'm just not sure about this true because we need to pass the old type and the new one. Is that correct?
Yeah.
And is that
The
this true?
abstraction, label, kind,
Yes,
type
yes, 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 yes. It's type prime
definition.
and type two primes. I think that's correct.
Alright.
Okay. This tilde, man, it bothers me because this keyboard doesn't have it that well. I need to swap the modes to type that thing. Okay. Thankfully, I'm not using it here. Like, imagine.
Let's see.
Okay.
This will not compile at all because we have the type checking and the evaluator totally broken at this point. But
Yes.
okay, so let me try to read it then. So if you have a type abstraction, you have a name that we're calling label, we have a kind, and we have the type of that. And then if
Mm-hmm.
the label is equal to the one that we are looking for, which is the placeholder, then we need to create the type. We just create the same type abstraction with the same label and the same kind, but swapping the kinds. So if you have
Open the kinds?
is that should that be type prime twice? Shouldn't that be type prime only?
Wait, can you
Or
repeat from the.
the
Yeah.
beginning? Yeah. Okay. So let's suppose that you have a type abstraction, and then you have a name, which is a label. You have a kind,
Mm-hmm.
and then you have the type of that, which is okay. Then, if the label matches the one that we are looking for, which is the placeholder, then what should we do? That's the question. That's a question.
Oh, this is the shadowing case, right?
This is the shadowy case.
Yeah,
So we just do
because you
nothing.
match the same. Yeah, you just propagate it.
Okay. Um, in this particular case, we could use the at operator, so that we don't have to literally type the same thing.
Can I was questioning how can I use it here like this?
Yes, you're gonna have to wrap parentheses this thing.
Okay, this whole thing.
Yeah, but the at is before the parentheses. The at. No. You need that. Also need the label and the
What?
kinds. Yeah, the
So,
beginning. Remove this at,
so now let me ask you, like,
and before
your
the
suggestion.
parentheses put at,
Oh,
and then you're
this.
gonna put I don't know t abst t abstraction. I don't know with the non-capital T.
Type abstraction just to make Nathan happy.
Yeah, and then you're gonna put that inside of in the guard, the
And
first
what about
case.
these things?
We need those things to do the otherwise.
Okay.
So you're gonna
Yeah.
just put in the first guard instead of T abstraction all of that. You're just gonna put type abstraction with the
This one.
yeah.
Lambs.
Go.
That's like almost a one-to-one of the code I did. You see the at, it's the same thing as the S.
No.
And you
Now
saw
you
that
can
you
understand.
didn't.
What I was not understanding is that the match width that you were doing there is also doing type
Oh,
underscore.
okay. You were
And in mine it is
confusing with this one.
target, right? So confusing in my opinion, but okay.
No, but you saw you are not returning target, right?
I'm not returning target. That's okay.
You did the S, right? But
Okay,
let's go.
Okay.
let me see.
But let me continue then. If the placeholder and the label don't match, if they don't match, then we create another type abstraction just asking for type substitution inside. That makes sense. Okay, so type substitution is done because it doesn't have the warning anymore.
Okay,
I
now
want to fix the
let's
other
see.
problems that we have though.
Where is
So
it?
line 20 down.
Arbitrary.
Yeah, what is the
Screw
problem
this
of
shit.
this?
This is the 3 garbage.
No instance for arbitrarily kind.
Oh.
Oh, we need to add that. So instance, just copy paste those 2 lines there.
This?
Yeah, those 2
Okay,
lines.
this is for the tests, right?
Yeah, this is
The
for
generation.
having arbitrary stuff. Just swap t for info with kind. Okay, so let's scroll down this file to see if we have any other errors. Okay, that seems pretty
No,
good.
okay, but we're gonna have it here, I guess. Hyper.
Yeah,
No, we
this
don't.
should we should have
But we should.
we should have a warning in here. Oh no, wait,
Oh,
should we?
we're not having because of his
Oh, the
things, I
type
guess.
environment is actually.
No, I don't know about this, but type abstraction. Type check environment.
Yeah, we just need to care about type check with environment. Type check is just an alias passing empty stuff. Okay, so how do we do type checking with the type operators? That's a good question, I guess.
Are we lacking something still, like warnings wise?
Oh, I can try compiling. Let's see.
Yeah, we can try compiling. Why not?
Let me close my Nexus.
Okay. Let's go build.
You said like you were like, I don't know, man.
It's because I usually
Disgusted.
want to go to the REPL to play around.
It looked like you were disgusted. Like, let's build.
I prefer REPLs though,
For
so
all.
that's my thing. Okay, so the
the
typer.hs has a problem on line 70 something.
Typer.hs.
Typer.hs.
Line
78.
78. What? It's not even
Okay.
complaining of this line.
Yeah, I don't know why. I think
And the
that
LSP is working. Okay, but yeah, we're liking the kind here.
Yeah, we're definitely.
Oh, okay. So let me maximize this, because now I think we're gonna change it here.
Yeah, line 5 up is already
Wait,
breaking.
what is that code anyway? What is that doing?
That is trying to.
Oh, okay, we are doing pattern match on the top level, right?
Yeah, we need to do stuff with we are checking e-type abstraction.
Okay, let's go one by one, because there's many here.
What is the kind? Wait, do we have this information though? This info?
Let me think. These.
Wait, why don't we start with the simpler ones?
Because I don't think the simpler ones involve the kinds.
This case is simple, right?
They do.
They do? Oh.
Of course.
This case, don't we just check? Oh, let me think. We just should check. Is the kind match? Okay, just passing by, isn't it?
So let's see. We have a type application, right? It has an expression and a type.
Don't we need something to check this kind as well?
Yeah, we need, we will use the kind equal, right? To see if the type.
Oh, makes sense. Okay.
Yeah, but first we need to do the thing that Lem was talking about.
Wait. I want to go back a little bit. Can you repeat that? Why do we need kind equal in here, Nathan?
Okay. So from the beginning, we are doing a type application. We are applying an expression on a type, right? This expression is expected to be a for all, right?
Yeah.
Yes.
So, okay, we are checking already the type of the for all, right? And then we want to apply a given type on it. But you see that we need to check the kinds if they are the same? Because
which
our
ones
for
needs to be
all,
the same?
we only have 2 kinds there.
Yeah.
So we have the kind of your
Okay, that makes
argument
sense.
type.
It's not if, Mageta, it's case off. Case kind of.
Case
Case, yeah,
kind
because we're doing pattern matching.
of.
Just 1 second, people.
Do you? I don't think you need that to pattern match the kind.
Yeah, we don't.
Yeah, we have the equality.
Yeah, it's an if indeed.
Let me see. Maybe here. Where is it? Ek. Was it? Here, so it's just using the same ek. Is that it? Yes, right?
What do you mean?
Like, okay, when you do ek here in Haskell, it's just a constructor for.
I'm back.
I
No,
got
no,
it.
he's
Yeah,
doing. Oh, okay.
we
Now
do
I
it this way.
can do equality for this data type, right?
Yeah. So okay, let me just see. The Haskell thing is
Wait,
this,
wait,
and then
wait.
in this case
Why
we
do we
need an
need?
else.
Why were we using if instead of case?
We need it.
We need why?
Yeah.
Hey,
So
don't want.
we are checking the kind of
I can do
for
with a
type
case, by the way. I think.
that is an argument, right? Oh, you would be, you would be doing a case of in true or false, right? So,
Yes. Kind
uh,
of.
well, some people prefer that, but anyway, like we have a type that in our case is our argument, right? We will check its kind, and then we need to check does the kind of the argument matches with the kind of the parameter?
Don't we need kind checking?
Yeah,
We
we
need to
do.
check
That's what
before
I was
this.
about to say. Like,
Yeah.
Oh.
remember what you
S-
said like a bunch of time
So
ago
we need a function
regarding
called kind check that receives the ident type.
Mm-hmm.
this is the what?
Ident type, I guess.
What's the dense type?
It is the one the in the line on the left file below above the if.
Uh, I'm not.
On the left file, we have if kind equal equal,
Oh,
and
no,
then
no, no, no,
I
no,
guess we're gonna
wait.
have a kind check that receives the ident type. That's my guess.
No, 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 wait. Okay, we have an argument and a parameter, right? So what is our argument there?
A kind and a parameter, you said, right?
No, 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 no. I said an argument and a parameter.
An argument and a parameter. Where?
What is our argument?
Where?
Well, this is application, right? Type application.
Oh, okay. The argument is the
So,
type, right?
okay, and it has a kind, right?
Yes.
And I want to apply in the like function, right?
Yeah.
So the function has a parameter. What is the sort of this parameter? He's constrained, right?
What is the sort of this parameter? It is its kind.
Yeah, so we check kind on the line 8, right? With the kind of our type argument.
We check. We
Hey,
check if the
sorry.
kind. Can you repeat the last line?
Yeah, just a sec.
We check if the kind of type prime is equal to the kind of that we are receiving in the for all.
Wait, can you repeat?
Yes. We check if the kind of type prime is equal to the kind that we are receiving in the for all.
Yes,
Ah, okay, I see.
because the ident type, it's the type of the body, right, of the for all.
Yes.
Yeah, but that is a thing that we also will need to do, right? So what if the for all it's something like for all A to A, right? How do we infer the kind of this body of the for all if A will mean nothing, right? So
Wait, that question is getting harder with time. Can you repeat?
let's just wait. When we implement the thing, we we will
Okay,
need to
so
do that.
what do you want to do, Magita? There.
So I want to make the kind of function.
Okay, so you want to. What is the kind of function? What should the kind of
Let's see.
functions do?
By the way, remove the thing regarding bounded type variables. We don't need that anymore.
Bounded type variables.
Where?
Yeah, on our env, in our env type.
Oh, I see. Can I hop there?
You should be able to using no. You should be able to use that with
To
comma,
dot.
a dot. No,
Yeah.
meta dot, or I think.
Yes, meta dot.
Maget is too used with clicking, man.
Oh yeah, I became a JetBrains dude,
Clicker.
Try
unfortunately.
try
It's
meta
not working.
comma also if you try that.
Oh, it's Metacoma. Oh no, that's just a signature.
One of
in
them
Haskell.
go and another one goes
Yeah.
back.
Anyway,
I don't forget. I don't
it's just
remember.
here. Yeah, but I was thinking, don't we need a context for kinds?
Yeah, we do.
So
So we
you
have bounded
said
kinds.
Huh?
We have bounded kinds, I guess. Is that correct?
No, wait. Uh, so first of all, delete these bounded types.
Why?
yes.
Why? So okay, why don't we have bounded variables, right? Oh wait, just a second.
Wait, I'm confused. Don't we have bounded variables?
No, wait.
Yes, I'm
What
confused
I
as
mean
well.
is, when you are, how can okay, I have a good one. So when you are type checking abstractions, for example,
Type checking
why are we,
abstractions. Okay.
yeah, why are we not keep tracking if some variables are like in some set of bounded variables or something like that?
Because they are unique inside their context. If
Uh, no,
if I
no.
got the question, that is it.
Yeah, like, so okay, when we have a free variable inside an abstraction, how can we detect? How can we say that that's unbounded? When are we doing that? In which step are we checking that?
Oh, if
Wait. In which step are we checking if we have a free variable?
Yeah,
Uh, uh, are we doing that at all?
of course.
Oh, we are. Okay. So can you scroll down, Mageta, to type check with environment in the case of in
Uh,
abstraction?
you could search in the
uh,
text also
yes,
unbounded something, right? We are probably using neighbors.
Okay, so
yeah.
there we have there. So type check with environment in E abstraction. We have a label. Where are we checking if we have a free variable?
We are doing errors, right? And try to look for unbounded
Yeah,
in the
do
text.
use swiper to get unbounded. Capital U though.
Variable.
Just put unbounded with capital U. I think that's gonna be enough.
This one.
Could not find.
Yeah, pretty much.
Yeah. So
So
okay,
okay,
go on.
that's how we are doing. If we have a variable, we check if the environment to see if it's bounded or not, right?
Yeah.
Mm-hmm.
So we are doing that at the type check, right?
Yeah.
But now let's suppose we don't have the type checking, right? So we only have the evaluation.
Hmm. Okay.
So if you think about those steps, they are doing checking on our sorts, right? So think about the evaluation as acting in the expressions, right? They are like checking the expressions or evaluated, it's what matter for us. Then we have type checking, that is checking the sort of types. And then we have kind checking, right?
Yeah. Okay. Go.
So, okay, uh, if we had only evaluation, right? How would we check if the thing is unbounded then?
We wouldn't.
We wouldn't, right?
We would just throw an arrow.
So, yeah. So, what would be a way to keep track of that? We could do the following. We could make a set, and when we are evaluating some abstraction, then we check if the thing is on the set, if it's unbounded or not, right?
Yeah, we could do that.
So, you see, when the evaluation is alone, we need this set to keep track of. But when we have a system on top of it, then we don't need
Oh.
anymore because the type check is doing.
It's because when you add another layer, the below layers they can be lazier.
Yeah.
They
Not lazy, right? But there's an order in
It's because lazy is a tricky word
precedence.
to use in
Yeah,
this
Yes.
context.
I'm I'm reusing it just for the joke. So as you go forward, adding layers on top, the layers that are below the top one, the toppest one, they can they don't need to check the same amount of things as they would be doing if the new layer was not added before.
Yeah, that okay, that makes sense why you delete the bounded
Yeah, that
because
makes sense. That makes sense.
Because now, when we find a type variable, we will
Mhm.
check in the kind context, right?
Yeah.
Yes, yes.
So I would not put at general as you said, because I'm not sure if it applies for everything.
No, but it really
But
makes sense to like. I'm not I don't have pencil and paper to prove like with an induction stuff, but with intuition it makes a lot of sense.
Just learn this.
Okay,
Anyway,
but then the question becomes, should type checking do some sort of kind checking? Shouldn't we have kind check also, a function called kind check?
That's the kind of it, right?
Yeah, but should we have this like on inside the typer? Shouldn't we have like a kinder?
Oh, wait, man.
kinder.
Let's just do this
Let's go
function
to
first,
the
right?
kind check.
Can you
Okay,
Oh,
remember?
you need to
let's do
change the
it.
name on the signature.
Yeah, you need to change the name on the
Oh,
signature also.
Yeah, let's start with just making the function names. Then we see where to use it.
okay. So let's do the case. So it's gonna be
By
the
the way,
ugliest
why are we
Haskell
not
code you've
using
ever
the
seen.
top level in every function, only in the type checking?
Wait,
Why
what
are
do
we
you mean?
not using the top level?
What is the mean by
Yeah,
top level?
like top level pattern matching, I mean.
But we are using top level
Not
parametric
on
matching.
type substitution.
Oh yes,
And
no.
not in kind checking also, right?
Oh,
Well,
that was
yes.
just personal preference in the type substitution.
I will just do this way because I wanna look it. Okay, so
Oh no, I know it's not because of personal preference. It's because in the type substitution we want to reuse the same placeholder in type prime, and we just want to pattern match the target.
yeah, here just like pattern matching the things and this memory already,
Yeah,
right?
but sometimes we want to dismember the type env, sometimes we don't. We don't. So okay, so what do we need to do in kind checking? Can you make a summary, a roadmap for us, Nathan?
Okay, so on type checking, you are
We
getting an
want
expression and like
like a
inferring its
literal,
type, right?
yeah, like a literal, for example, turns into a star, an arrow, we just convert it to an arrow with stars and so on.
Wait, but then I have
No, wait. Can you repeat that, Magenta?
Yeah, like for example, a literal, like integer. What was the integer type? I don't recall. But anyway,
wait,
an
but
integer.
the signature of
Wait,
kind
let
check should be
Magenta
type
finish.
env type to kind. We are missing the result type, Mageta. Also.
Yeah.
We're missing the. Oh yes, that's true.
So that's a kind.
Con.
Oh, now I am understanding why we need this more. Okay,
Yes.
sweet.
Okay.
So if
for
you have a
example,
literal, I think it's T
I think
literal.
it's T. But it should be the literals. These things: unit, integer, rational.
We don't have
bool.
this. We don't have disjunctive pattern matching, so we need to do the other ones first. So let's make
So
this one
this. What is the kind of this?
star.
So that's
Yeah,
it.
remember the thing I said regarding
Star. Okay.
that the kind is star? It's the kind that describes a type that describes the expression. Like that's important for a bunch of stuff, man. That's one of those cases.
What? Okay, Max.
Okay, so you need to, because we are not using, like we are not short circuiting everything else because we are trying to, because in type substitution I also did that, right? The last one picks something on the left and just returns it, but Nathan said that it's better for, and I agree, it's better. It's just annoying. So T integer, T rational, and T bool, Mageta. All of those they are stars in the kind level, and that makes sense.
Is it bool or boolean?
Bool.
Yeah, bool. Okay.
Okay, so let's go to the
Now
complicated ones. T
No.
variable.
What do
I
you mean
think
this
it's
is not
the
complicated, man? The
T
amount
variable.
of stuff you gotta. T variable. Okay. Okay, it completes. That's cool. So a variable.
It has a name. It
Wait.
has a text.
Wait. Okay, Emacs.
Oh man,
Gone. Record.
I had
Let me
flashbacks.
save.
I had
Let me save.
flashbacks.
I saved. Okay, so label.
What do we need
Okay,
to do with this?
we need to find it in the context of the name, and then that will be the kind.
Okay, so let
So
I don't know. Yeah, exactly. Something we need
how
a
do we
name now.
find something in the Piper env map dot?
No, wait. Can you
How do
go
we
to
deconstruct this thing, by the way?
go yeah, dot.
This?
Yes.
Okay.
Go to
Leaky abstraction. That was I have to say, man.
what?
Find.
Leaky abstraction. That's what I have to say
What do you mean by leaky abstraction though?
about our type env. Or typer-env, I mean.
I know. I
Kind.
still don't understand what you mean, but okay.
Dude.
Leaky abstraction, like you are leaking that
Oh
typer-env
yes.
as a map inside, and they are composed of two things,
No,
right? It's not
of course.
abstract.
But that's fine. We are the developers. We have access to this, man.
That's bullshit.
No, we are not
Yeah, that's not a
exporting
good
this to someone
argument.
else. We are
That's
using
just
ourselves.
bullshit, Lemon.
No. I still not convinced, but okay.
Man, just because you are handling
Yeah,
all the
it's,
code doesn't
yeah.
mean that you don't have to separate like modules, concerns, contract, abstractions. Like,
Dude, why is he not checking? Dude, let me close Emacs and open again just a second, guys.
But just save that. I agree
Yes, he
with you
did.
that that doesn't mean it's not because I am using that we should have access to in all contexts, like all possible contexts. But in that context, it makes sense because we need both, as far as I
nope,
can
it
tell.
doesn't.
I guess the point is different. It is that
Don't we need
you are
both? I'm
basically.
confused.
No,
No,
I
we
guess.
need both, but we shouldn't know about the implementation details.
Yeah.
Oh, you're talking about creating an interface to access the environment. Yeah, we could do that if you want.
Yes, but we will not. Not with me in the
Go to
control.
type check.
So
Go to
what
type.
is this find, man? I just want to see the signature of this crap. Okay, thank you. So,
Do you see
oh, that's not
the
good.
lines 24 up, Magita?
Wait a second.
24.
24 up.
No, not anymore.
Right. Okay, now
Yeah, 24 up. Do you
24.
see that let there? This is kind of what we want, but
Yes.
instead of
Okay, I see.
set.insert, we want set.lookup or something like that.
Look up.
So
Wait, not set, right? But
yeah, so look
Look
up.
up.
So you pass the key, you pass the
Dude,
map.
I don't know why my you see the thing there
Yeah, I see
on
it.
Haskell it moves on the opposite direction on where I press. I don't know why. Just in Haskell, like in every
I
other
never
language.
had this experience, but okay.
Yes,
for the
anyway,
laws, as
Just for the
Lemon
yeah,
laws,
say.
I guess.
just to.
Man, there is an example of lookup. Wow.
So okay, it's gonna be just the name and the thing, and then it just I think it's pizza maybe, right?
Yeah, it's pizza maybe. We're gonna have to pattern mesh that later.
So that will be the label.
And the map
What?
is gonna be um
Env
no, not env.
dot.
Env
Oh, not it's the. I'm doing like .net garbage. Okay.
it's just
Uh,
variable
I think it's
something.
kind of context.
But is that a map or is that a set? Go up to the type.
That's a map, I think.
I don't recall at all.
Kind context, a
Yeah,
map.
it is a map.
Oh,
Okay.
is it right? Okay, it's right like this, right?
Yeah.
Text to kind.
Yeah. Okay, so
Okay.
now in case of oh, we need to get have a name for that. That lookup returns
Oh,
something. We
yes,
need
that's
to
true.
bind that to a name.
All right.
Uh,
So what would that be?
um, um,
I'm better than
bounded kind,
X.
X.
What about kind?
No pipe there. No pipe. No pipe.
On the first one you don't, right?
No, in the case of we don't have pipes. Instead of X,
What?
put kind. Instead of X, put kind.
Is it just this? Are you
Yes.
sure?
Yes, I am sure.
Why am I
Instead
doing
of
this then?
because this is not because this is also wrong. But I forgot to tell you.
Oh, so it should be like
Wait,
this?
what do you mean by wrong? Like,
Yeah,
doesn't compile?
doesn't compile. Doesn't compile.
What? Okay.
That's fucked up, man.
Uh, now instead of X do kind, please. Nathan is right. Kind. Then if we have just what is the return of the lookup again? I already forgot.
Should be this, right? Because it's not really a kind yet.
It's not that.
Now it is a kind.
Oh, I don't know if that's gonna work. You're doing shadowing on the name.
Well, I
No,
hope it
come on,
does.
man.
Dude,
Come
if
on,
it
man.
doesn't, dude, what the heck?
I
What
hate
the
it.
fuck is that
I would
language,
never
man?
do that, but okay.
And yeah, that's wrong
Don't
indeed. Like, it's not a kind. It's a
actually
kind,
should be
like, maybe, right?
either. Should be either
No,
in this
no.
case, right?
Should be exactly as we have a type of result. Do you see type of result up there?
Oh, fuck yeah, I
We
Yes.
need
forgot this.
a kind result also.
Where's
Wait,
type of result?
why do we have that type alias? Oh, just for.
No, we
I
need
see.
that because if you do it polymorphically, we're gonna have to implement a bunch of extra stuff, which I don't want to do.
No, thank you.
What do you mean, man? Like implement for what?
Well, I don't remember anymore. I just tried and it was bad, and I don't want it.
Which one is it? Is it
No,
left
no,
or
no,
right?
no. Left is the error. Left is the error. This is the
Oh, but I hate
convention
this.
global.
I hate
Man,
this so much.
right is the right one. Just think
Right is
about
the
that.
Okay,
right
this
one.
is correct.
Okay,
Okay, yes.
nothing, arrow. What should we
Okay,
do if you have a
and
nothing?
kind mismatch, something like this.
So left, and then there, yeah, that.
Kind, uh, think of a .NETized error message.
Like unbounded type variable, man.
Oh my god.
I'm willing to try an example just to test. Unbound type variable. That's not a good one, but that's
What do you mean, man?
Okay, so what is the next T
um
with T
arrow.
arrow, I guess? I don't remember anymore. Oh, it has there. Okay, type
Thank
to
you.
type.
Yeah.
So we
So
have
Auto completion, that's nice.
yes. So
the input
input.
and the output, I guess.
Why is doing this? Okay.
Arrow, enter.
Okay.
Okay, so
So
what do we need to
let's
do this
think.
one?
We need to
Oh,
find. Let me
okay,
think.
so wait, let's think about this way. Is a type that is describing an expression, right? What is the
Hmm.
expression that is describing?
Well, an arrow, like a function.
Yeah,
So
a
So we need
function.
it's
to,
Like
yeah. So we
it
need to
doesn't
pick.
really matter, but
Yeah,
but it
okay.
matters that it's describing an expression, right?
I
So
So we
then you
need to
no
can
wait.
pick.
conclude what is the kind.
I think
Okay,
is this the
yes.
one that is recursive?
Yeah, because we need to pick the one that is here, the one that is here, and then we just check which one are both, and then we just
Yeah, but I think it's gonna
compose again.
be arrow. Don't we have a kind for an arrow on the type in the data type?
Yes, we do.
So it's gonna be
But I
that.
don't. No, but it's not only that, right?
Hmm.
Because this thing.
Are
Let
you
me see.
sure?
This thing is a star. This thing could be a star, for example. This thing could be an arrow.
No, but both of them could be whatever, right?
Yeah, that's what the type system says.
Yeah. So my idea is to do the following. Can you open the data types again on the right, Magita, please?
Data types
Yeah,
again on
the
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 right.
AST, the AST, and types.hs.
Closed. This one, right?
Yes. Okay, so if you go down the kind, we have an arrow K. So
Yeah.
my idea is to go back to the panel on the right, on the left. It's gonna be the following. This is just a guess. Maybe I'm wrong. Arrow K.
Uh, arrow K.
Yeah, start arrow K with arrow K. No, with capital,
Oh,
capital,
okay. I see. I see. I see.
and then in the parentheses, you're gonna do kind check, passing the same environment, but asking for the input. Env
Passing the same env
and input.
and input.
And then on the other parentheses, you're gonna do the same but with output.
Okay. Yes.
Is that correct, Nathan?
Oh, wait, I'm just getting something.
Kind check env output.
Good.
Okay, I just send the link here so you can take a look later. But okay, what was you saying?
But this can represent. This can represent itself just a star.
Wait, can you
Can
repeat
it?
that, Magetta?
Let me think if this makes sense.
Let me give you context, Nathan. We need to kind check a T arrow, right?
Okay.
And the idea that I had, which I don't know if it's correct, is just a guess, is to say that the kind is arrow K, and then just call recursively kind check in the input and in the output.
No.
Okay, why then? Why it's not that?
Because it's not something else.
Yeah, no, you can start by saying what is.
Okay, Mageta wants to reason about the thing first.
Yeah, okay.
I'm thinking because can this because I have a feeling like okay, like what Okay, let's just do a let. And these two things here, they can be, I don't know, kind input
Yeah.
to this, kind output. So they're
Yeah.
both
Oh, we need
here.
fucking do notation, man.
Oh yeah. Cool.
Okay,
I am very.
let me do it here.
Oh, is that why is it wrong then? Because we need to check if you have an error in the input, we don't do on the output.
No.
No. Okay. So that's. I still don't understand the do then, but that's okay.
Yeah, I don't
No, no, the
understand
do
that.
is because it's returning a result, right? So we want the
Oh,
kind.
okay. No, okay, that I can understand. But let me help Mageta. Mageta, when you have a notation, you don't do lets if you want the monadic action to be like.
Oh, okay,
So
see.
you just do remove the let, and instead of the
And do
equal, you're
arrow.
gonna do the arrow to the left. Yeah.
Yeah.
You have a
Sa-
funny left arrow.
same thing for the kind output. Same thing, and you don't have the in also.
Mm-hmm.
Okay.
Okay.
So now I want. I agree with this. I totally agree with this. The kind check returns an either. I forgot about that. So the kind input has type kind, and the kind output has type kind. What else, Nathan?
Uh, so Magenta.
And I don't know, man. Like I don't feel like an arrow represents an arrow as well.
Yeah.
Because here's what I'm thinking. Do you remember the F star talk that I was
Yeah,
talking about the words and blah blah blah?
yeah.
Not the words, the worlds. And where does this live in? Like it's the max. Like think of the type, the universes, blah blah blah. It's max of a. In this case, not a good one. Like it's the max of this, right? But what
I
if
I think
this
I think we
two
have a plus one somewhere, don't we?
a plus?
Yeah, I remember that like when they are classifying things like order and such, they do like in an arrow. They do max of one side and the other, but I think they have like a plus one in the
Oh
left.
yes, yes, it will be plus one. Yes, but here's the
Oh,
problem.
okay.
It
Wait, I think I got your point.
but the
The
point is like if this is just the same plane, then this is not like an arrow is lifting the thing above, like to one world above.
wait, can I try to let me just I think I got the main point that you're saying, but I want to understand. So let's do a supposition. Let's
Okay.
suppose that the type A, it has the kind star to star,
Okay,
right?
let's this.
Yeah.
So it
So
is an arrow, right?
yeah. So
Arrow kind.
arrow, and then
Okay.
star K, star K,
Star K.
star K.
Star K.
And let's suppose that the B has only star K.
Okay.
So now the question becomes, what is the kind of this entire function?
So in this case, I think it should be this, right?
I'm not sure. Uh, shouldn't be the sum of them?
What do you mean by what is the kind of that?
Yeah, because we know the kind of A. We know
By
that
the way, the max that Magetta is doing is not regarding what is its kind. It's
Yeah.
regarding something else.
okay, but anyway, I just want to pro- see if I'm understanding something. We know the kind of A. We know the kind of B. We want to know the kind of the function from A to B.
Mm-hmm.
So that's my understanding, right?
Yeah.
So in my
Let's
mind,
think of the base case. So what if it's a star to star?
then
Then
it's
it's just a star.
wait.
Is that correct?
I don't think I understand what is arrow K then. What is
Magetta,
arrow
it
K?
is correct.
Okay, why? Okay.
Okay, dude, like remember about the thing I said.
Hmm.
Star K, it's a kind that describes a type that describes an expression, right? So
Okay.
a function is an expression. So doesn't matter which
Oh,
type it
right.
is, it's kind of big star, right?
So from this idea, then every arrow, like it doesn't matter what is in here, will always be a star. But then you need to check if the thing
Kind
is
of.
No, wait.
Kinda.
I'm still lost. Why star k to star k has the kind star k only? Why does the function has this thing?
No, wait. Forget about the star k because that's a kind,
Let
right?
me see here if I can make a parallel. So this is mapping an expression, right, Lemus?
Yes.
So what is
No, not really.
Well,
no?
You don't have like, how can I say? That's not expression to expression, right? So it's not a like
No,
a
but
function.
this itself is an expression.
No,
No, what the heck,
no,
man? This
that's
is
a
a type
kind,
of an
right?
expression. No. I saying like an arrow, like
No, yeah. So okay,
B.
this is an
yeah.
expression. Then we
Yes.
can ask, okay,
At least the type of expression.
yeah, this is a type of expression. In this case, is a type is an arrow that picks an b and returns an a, and these are just types. So then I proposed, okay, so let's suppose that we know the kind of the b and we know the kind of a. So then we have we have a function that picks something with certain kind and returns something with another kind. What is the kind of this function? That's my question.
Yeah. So see, uh, what the function does, like what the function does. What is its input and its output? A function.
The input is a type.
No. Wait. I mean the expression function.
Okay, it picks an expression and returns an expression, I guess.
Okay. So what is the types of expressions, right? You have like a bunch, right?
Yes, okay.
You have a bunch of types. And what is the kind of a type that describes the expression?
Wait, say it again.
What is the kind
Yes.
of
A
a
type.
type that describes an expression?
Is it
Isn't that
just
what we're doing right now, the kind
yeah,
checking?
just star?
No, not really.
No, okay.
So let me do the other way. Okay, so we have a T arrow, right? T arrow is a type, right?
T arrow is a type,
Yes.
yes.
Okay.
What is it describing?
It is describing a type of a function, an expression function.
Yeah, exactly. So we have a type that describes expression. So what is its kind? That's already enough for us to tell what is its kind. Because I told you that the star k, it's a kind of a type that describes an expression. So since it's a function, it's an expression. Since it's an expression, it has a type. Doesn't matter which type it is, it will always be star k, the kind of
Oh,
the arrow. That's what Mageta like said, and it's
Wait.
right.
by the totally wrong reasons. But I get it.
Wait. So let me repeat what you said because I don't think I understood what that means. So if every single time the kind of a type that describes an expression is star k.
Yes.
Every single time a kind of a type that describes an
Repeat Spentler,
expression is a star
repeat three more
k.
times, and Harper will show up in your.
No, this is how I graduated, by the way. My TCC was only that.
What do you mean?
I,
Repeating stuff?
yes, we have a lot of I had a lot of conversations with my advisor in which he said, "You understood. You just need to convince yourself." And then I kept saying this, like, during the nights, and I said, "Okay, wait."
I can imagine you like going to the bed, like sleeping.
Nike.
uh, so the case in which a kind of something would be arrow would be type operators
Yeah.
and such as maybe and either,
Uh-huh.
because expressions are pleb. So it's
Yeah,
always star.
basically, they are low sort. They are the plebe sort.
Okay, that makes sense. Okay, I convinced myself.
So
Right?
the ones. So let me think. The one we would have an arrow, for example, are the ones that we have to that we will have to. They're greater. Like for example,
Yeah.
the type abstraction.
Yeah.
Okay.
Maybe and
Yeah.
neither.
Dude, how did you do this shit? Let me look. I'm cheating,
No, but
but
I know the answer. Can't you just don't
Yeah,
look?
no,
I know
don't
the
look
answer.
yet. That let Linus
I
do it
want to. I
first.
want to. I want
okay,
to.
okay,
I
okay.
want to try. So you want the
Just
result of
one thing
this?
first, Linus. Just
Go.
one thing first.
Go.
So you said right. The kind that will be an
You're
arrow.
missing pure. Pure star K.
It's something like
Yeah.
how can I say?
But we need to check this.
Type
Right?
operator, right?
No, wait.
But
Stop, my Nathan. Just answer, Magetta. I don't think you need to check.
Oh,
Uh,
but what if this is not what you expect? Like these two things need to be stars, don't they?
they do.
okay.
That was the point.
Oh,
Yeah, because
okay.
if you have something else, then it's a mismatch. That's
Like it cannot be a type that is describing a function, right?
uh, kind.
Wait.
Oops.
Can you repeat that? If the input is a maybe, then we have a problem. Is that it?
It's because it's a function. Like it needs to receive expression. So its type cannot be a maybe because there is no expression that will
Oh.
match a maybe, right?
How do I match this like this?
Yes.
I don't think
Okay.
you need the parentheses though.
No, you need to make that a tuple.
Really?
I'm not sure, but you can try. You need the underscore also. Instead of you do underscore arrow to the right. Everything else you're gonna do a left,
Left
and then we need to
and
make
then
a very creative error message.
Don't ask me. Good luck next time.
that's it. Or we could make it angry. That's it.
okay, okay, that's the end of the denotation. That's the end.
Yeah. Okay. Okay. This. Oh
This is
man.
elegant though. 5 lines,
Yes.
6 lines. Sorry, with the do. Okay. Ah,
Yeah, the thing that I was about to say,
I'm still
Linus.
wrapping my mind on that, man. I'm repeating.
What about make it shorter? Every expression will result in a kind star.
yes.
Every expression
Yes.
result in a kind star. Yes.
Yes.
But okay, so then you said, right? So what do you result in a kind arrow? It's something like a type operator, right?
Yes.
Like a
Which, by
maybe,
the
like a,
way, I need to discover if type classes are always type operators. I need to discover that.
that's really interesting. That's really interesting. Uh,
So which one now?
it's really interesting. Just one thing. So you
Okay.
said type operators, right?
Yeah.
The type operators themselves here they are the T abstraction, right? In our types,
Yes. Yes.
but T application can also have a kind that is error, right?
Yeah, the left
Because
part is a
suppose,
T abstraction and the right part is a type, right?
yeah, and they don't necessarily need to result in a star, right?
They don't necessarily need to result. Yeah, they don't. They don't.
So can you do partial application of type operators in Haskell?
Yes.
So yeah, that's the why.
Wait. I said without thinking. Can you do partial applications of type operators in Haskell?
Yeah, can you do a type alias is equal to either and then passing only one thing?
Yes, you
Right?
can.
So, okay, you see that that's an application, right? The abstraction is the either, and you are passing something, right? But what is it? What is it returning? Is it still expecting another type, right?
Wait, just a second. Magetta, can you can you go to the shell just for a moment?
To the shell.
Yeah.
Okay.
Close this. No, not close. No, don't
He
close the
wants the
shell.
REPL.
GHCI. Open GHCI.
Okay.
You're gonna do the following.
Hmm.
The
T
the
thing
no. I
was it?
want. What do I want? I want to test something. You're gonna do type. You're gonna type down, type, and then a name ABC with capital A, then space
Hmm.
A equal maybe A.
Okay.
Enter. Now, Yeah, so you do can. This is the proof, Nathan.
Wait
You
a
can
second.
partial apply type operators.
Let me
Oh, I
see.
see. Because
Maybe
you're.
yeah.
No, I don't.
So maybe no, that's
No, that's
no,
fully.
that's wrong. Like maybe expects only one.
Yeah,
So can you
Okay, I'm
try to
back.
use either
Okay, I'm back.
instead?
yeah. Like left and either. I think it would be a better
Yeah,
example.
try to use the either.
Can I use the same? I can.
Yes,
Right?
you can. In the repo, you can.
Either A, like this. Oh yeah, you can.
Yeah. So
Ask. No, ask.
see.
Can you ask at K column K ABC?
Column K, A, B, C. Oh,
Yeah, that's correct.
Yeah, it is.
That's correct.
So you see, either A.
folks, I gotta have dinner. Can
Wait,
somebody pick up?
no, wait. Can you go just a final test? Put up arrow. Up arrow.
Okay.
I want to have the either again.
Yeah, don't receive the
Oh,
A and pass like
this?
No.
int to
Before
it.
the A, before the A on the either, you're gonna put int with capital I. A space A.
Is A.
Enter.
This?
Yeah.
Okay. Then K again.
Ha. Okay. So you do can partial apply.
Yeah. So
That's
you
cool.
see, then either A, or in this case, like either int, like
Oh, we don't
A.
have to have evaluator result, typer result, and kind result. You can just do this. I forgot. Yeah. Nice.
What?
Because we have typer result, kind result, and evaluator result just as aliases, but I can just use this that Mageta just did. Anyway, continue, Nathan, and don't forget to commit. Mageta.
Yeah, I will. Let me just finish this.
Yeah, I still don't understand why we are using like kind result.
Because I didn't remember that you can partial apply aliases in Haskell.
But we would not be partially applying anyway.
Oh, we will.
We will,
Yes, we will.
but not on that type signature, right?
Which type signature you mean?
Like of kind check. There we know both, right?
No. We will, but I will explain to you after I get the code.
Okay. But
Okay,
man,
pushed. I'll be right back.
Okay, I will pause the recording and get ongoing with. Okay, go.
so suppose you have a bag of everything, right?
Yeah.
So we are not categorizing the content of the bag in any way, but we know that we have a bunch of elements, right?
Yeah.
So do you agree if I'm not doing any categorization there, right? Not distinguishing them in different categories and such, then they are only one category, right? So they are the category that have like everything, right? Not category in category theory manner. I
That's
mean
important.
categories. Yeah, that's important. I mean categorization. I'm not talking about sets. I'm talking about the bag, right?
Yes.
So trying to be informal here, because I don't know if it translates to the theory. So yeah, if you don't have divisions on your stuff, then you could say it has only one division that includes everything, right?
Yes, I agree with that.
So yeah, for example, when we didn't have types, we had only lambda calculus, right? Then we are not distinguishing one expression for the other because we are not categorizing them with something upper, right, of an upper sort. So yeah, that's the thing. We had different expressions that generate different types, and the types were not being categorized.
I also agree
So
with that.
so that's the thing. They were not only not being categorized, that's already a thing, because if they are not being categorized, it means we cannot validate them. Right? We treat them uniformly,
Yes, I also agree with
right?
that.
So if we treat them uniformly, we don't have anything to check, right? We're not distinguishing them.
No,
Uh,
talking in this manner makes a lot of sense. But what I was talking about before is that for me, adding more levels of categorization in the sense that you were talking about.
Okay.
I separate, like I literally think about those things as planes of existence.
Yeah, that's
But in
right.
my mind, they are not very intertwined. They are like almost parallel planes. But in here, uh, some of those changes that we do, they affect the plane that is immediately below the one that we're just adding. So for instance, we have expressions, and
Mhm.
then we're gonna have a type system. Then you create a data type for types, but then you need to add type information in the expression data type. And then
Yeah.
now we are creating the kind data type, but now this is reflecting on creating extra stuff in the type data kind.
That's a thing. That's a
Data
thing.
type, sorry.
That's a thing. Not necessarily.
But we are.
We are, but doesn't need to happen. What I mean by that? First, I explain like all the things regarding different categorizations and shit. And if we don't have categorizations, then we treat as uniformly. So that implies that you don't have to check anything, right? But that's only one part of the story. What is the other part of the story? The other part of the story is we are adding another type of type, another thing to not use type or kinds or whatever.
Yeah.
Another another thing, another way to do abstractions, right? That is the type abstraction, right? And that's really important. Why is that important? Because if we don't add type abstractions, right? Do you agree that we can still create kinds?
Okay, wait, can you repeat the question? I was
Yeah,
thinking about
go
hearing.
to our AST.
Yes.
So you see type abstraction, right?
Type abstraction.
Or
Here.
AST. Yeah. What if we don't add those? We don't add type abstraction and type application. Like you could comment those, right? So
No,
if
no,
we
no, but
don't
then you
add
have a
them,
problem. If you don't add, because you need to be also, because in my mind, we added those because of a single reason. Because we need those to explain some of those in that new level.
we don't.
We don't. Okay, so you
We
can
don't.
do e abstraction and e application without adding representatives of them in the type data type.
Wait, can you repeat?
Yes, you can represent in the kind level
Hmm.
um, properly the e application and e abstraction and stuff like that without adding these two to the data type.
Exactly. And you see, if you don't add the application and the abstraction, can you still use kinds? Can you still create a new plane of existence, a new universe, a new sort without having those two to describe our types? You can, right? You just don't need it.
Oh, so the real reason because we want those is because we want type operators.
Yeah. So, and because we want that
Ah,
and we want to check consistent between them, then we create kinds to check them, right?
yeah, that makes a lot of sense. I just stopped for a moment because I need to figure out why this is having a problem. Okay, so parser type. Why the parser type is complaining? What the hell? What are you complaining, my man? Line 44. Am I doing something fundamentally wrong? Oh, probably. This is type tab arrow and type for all. Um, okay, so let's just do undefined those. How is was Magetta? Oh, Magetta didn't pull the code. That's why his code was working. We're really lucky that we didn't touch the parser then. Really lucky because it's not compiling at the moment.
You could just like have stashed and then pulled and apply the stash.
Well, he could, but he didn't.
No, no, I mean, if we like needed the things, right?
Oh, okay. So the now the typer is complaining, and we still have one eval result left. in the evaluator. Okay, so eval result. Okay, we don't need that. We just need the result value. So much better, man. Okay, we still have this 0, but this is fine. We don't have the evaluator result, typer result, kind result. We just have result, and it's polymorphic now. Miles better. Okay, so what we were doing before? Oh, we were doing this, right? Expression arrow must have kind. Which notation we're gonna use in Silverware for this? We're
I
gonna
don't
use
know, man.
this or this?
Yeah, yeah, there are a few feelings. Well, I have some feelings about like both. I think that is writing type. It's more consistent, right? But it's also bad regarding reading in the sense that if it's the, how can I say, the asterisk notation, then you know like just in a millisecond, you
No,
know?
I don't agree with that take, because we as developers, we may have a confusion because we have this capital T Y P E, and we also have this thing. But for the user that is using the language, the only context in which he's gonna see type in this, like in this sense, expression arrow must have kind type. Only the user, I don't think the user gonna have a confusion, because
I'm back.
sometimes we talk about this and sometimes we talk about this, right? For the user, capital T is for kind stuff.
I don't know what you mean, man. I don't know.
Like it's a type ahead of types.
No, we are talking about which notation should we use. Should we use this notation or this notation?
I prefer the. I don't prefer using the word type.
Okay.
Yeah, like my arguments for one side and the other is that using the word type looks more consistent, right? But my argument for star is that when we are using like not star asterisk, like it's easier to see like with just a glimpse of it that we are talking about kinds.
It has the word, man. For me, that argument is very weak, but okay. Okay, so we need to finish how to kind check an T application, right? So what is a T application? A T application is when you have a type operator and you give something to it. Is that correct, Nathan? Or am I going crazy?
The application. Oh, okay, okay. Yeah, don't we have some others to do before that?
Maybe. Oh, we do have. No, wait. Do we?
We do, right? T for all, for example. The simpler ones.
Okay, so we have T for all, and that's it.
Yeah, the other two are actually easy.
For all. Then I'm gonna have a T for all info,
So
which is
to start,
composed out of a
uh,
text.
if I ask you guys, what is the kind of for all? Like, just by knowing that is for all, you can already tell like which one it is.
Wait, I never asked myself this question. What is the kind of a for all?
Wait, can you see
Kind
at
to
the right
kind.
side?
It's a kind to kind. It's
No.
a
I
type to
think
type.
this.
Sorry, a type to type. This type.
What about you, Mageta?
Uh,
This.
wait. What is the kind of a for all?
Yeah, I
That
think
it?
it's this.
Yes.
I think it is also a star.
Yes. Why?
Oh, because it's just representing a term, right?
Yes, that's the whole point. Yes.
But aren't
That
we
doesn't make
Lemos
receiving a
sense,
didn't
type?
right?
repeat it enough. Lemos didn't repeat it enough.
Yeah, but aren't we receiving a type of this for T for all?
Yeah, but doesn't matter. See, if you
Doesn't
look at
matter.
the ST4 types,
That
look in
doesn't
the
matter.
ST4 types, right? You see that some of the types there describe a term,
Yes.
Can you pinpoint which ones describe a
Yes.
term?
T unit, T integer, T rational, and T bool. They pinpoint the E literal.
Uh-huh.
The T variable, no, the T arrow pinpoints to E abstraction.
Uh-huh.
T variable, it pinpoints to E type abstraction.
No.
No. The T variable, isn't the T variable the, wait,
Do you have a term
wait,
that you will
wait, wait,
ask
wait, wait,
its...
wait. Well, by exclusion needs to be the E-type application.
No, man.
No, I'm confused then.
Yeah.
Go, go.
So, do you have a term in which you will ask its type and you will say, oh, it's a type variable?
Do you have a term in which you're gonna ask the type variable?
Well, we actually have. Yeah, we actually we actually do. But how can I explain?
Uh, let me explain.
E
Like,
condition is definitely not
Like, let's not think
this.
about type variable. Type variable is the tricky one.
Okay, the D for all is the E-type abstraction then, in my mind.
Yeah.
mhm.
And
What about T application and T abstraction? Do they describe terms?
no.
They don't, right? So you have ones that describe terms, you have ones that describe something else, and T variable is the tricky one because I guess it can represent both.
Both these, you say?
Yeah,
No,
the
no, both terms and types, I guess.
No, but that doesn't mean anything in regards to your question. Your question is not that do you
No, no,
have
yeah, just saying it represents terms, but not only terms.
which term C variable is representing?
Well, a generic one, right? If I do something like a for all, right, and I
Yeah.
say I receive a that is of type variable like x, and then I return the a, right? A will have in the context, we'll say that its type it's x. Like if we ask what is
No,
the
but
type
then
of
you're saying
a,
that no, but then you're saying, as far as I can tell, you're saying that the T variable is interacting with the T for all.
depends on what you mean by that.
No, my question is very direct. Which expression T for all is being mapped to? I said this
We,
before, right? This.
well, yeah, it is type abstraction. I'm talking about type variable, right?
No, yeah, but I don't understand. Your question was, can you pinpoint each one of these types to their correspondent expressions? And I said
Yeah,
yes.
that no, no, that was not quite it. I said for you to pinpoint which one of those represent terms, like represent expressions. I'm not saying they all do. That's the point.
You're not saying they all do. No, no, but that's the thing. I know that these ones they don't.
Okay.
But type variable for me it does. And the one that
Yeah.
I mapped was this.
Yeah, that's wrong. The
Okay.
for all describes the type abstraction.
Yeah, no, I also agree with that. But then
Okay.
I don't know which term the T variable is representing. That's my
That's the
question.
thing. Hello?
Yes, I'm
Hello?
I'm hearing you.
yeah,
Yes.
yeah, I can
Okay.
hear you.
So that's the thing. It can describe any term.
It can describe any term.
Like
Yeah,
it's
that was my
generic, right?
intuition.
What did you say, Maget?
No, that was my intuition.
Wait. A type variable can represent any of these expressions.
Yeah, it's just a variable, right? You need to find it. It can be a
Because a
star. It can be a
type
star, or
variable will be a type, right? You see that
Yes.
type variable is just a placeholder that will be used by other type.
Yes.
Then what apply by any other type apply to type variable.
I'm 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 just not figuring out this one. I'm sorry. The type variable
Yeah,
receives a type.
it will be
So
substituted by one, right?
yeah, so what does it have to do with expressions then?
If type variable can be any type, then it could represent any term, right? Because every term needs to be a type, needs to have a type. Like okay, that's nice. Think of type variable as being the
Can we
joke
write
there.
an example of that? Like fun A?
Yeah, I can. I'm writing the chat.
Okay, I will
See
see.
if I can write one.
Whew.
Like this. Okay.
Okay.
So what is x?
X,
Which terms can be x? Oh,
any.
x can be which term? Yes, exactly.
Mhm.
Why is
Um,
that? Why is that?
why is that?
Yeah.
Because A can be any type,
Yes.
and any type can potentially be any expression.
Yes. That's
Man,
it.
this is a very, very, very clear example that I'm still an engineer. I just learned by examples. That's it.
Just repeat.
I don't.
That works.
No, but that's the thing. Because in my graduation project, I have some non-exemplifiable stuff. That's why I needed to repeat to myself.
Oh yeah, you were dealing with math, right? So
Yes. Um, okay, so but then that means that the t variable is always going to be a star k. Is that correct?
no, 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 no,
No,
no,
no,
no,
no. The
no, no, no.
variable can be a star or an arrow.
Yes.
The variable can be a
Yeah,
star
because
or
you
an
gotta
arrow.
find. Yeah, because it's just representing something else, right? You don't know what that is.
Yet to be type, right? It's a
Yeah,
placeholder. So
Oh, you don't
that
know.
yet to be type, you see that it could represent a term or not.
yeah. It could be just a random type.
Wait.
In the same way that I can substitute a type variable for a type that represents a term, I could also substitute the type variable for a type that does not represent a term,
Oh, okay.
like
Okay.
the
Okay.
abstraction, right?
Okay. Okay. That did it. Okay, I agree.
Well, that's in higher kind of like
But I gotta
programming
keep
language, right?
hammering in my head that we're talking about both terms depending on types and types depending on types. I gotta keep hammering in my head.
Yeah, that's true.
Wait, maybe you confused with something. I guess you described dependent types also. You said
No,
types that
No,
depend
no,
on
he did.
terms,
No, he
right?
no,
didn't
I
say that.
said types depending on types.
Yeah, the types
Oh,
depending on types and terms depending on terms.
so yeah, we already know. How can I say? We already know its final result, right? We know that since it's a term, its kind will be star, right?
Wait,
Hmm.
don't we have three things? We have types depending on types, expression depending on expressions. Don't we have expressions depending on types?
It's the for all, right?
Yeah. So we have three stuff. Instead, so that we need to check the table. There is the magic table there
Oh man,
that
we're
Nathan.
finishing the say lambda q.
We have we have everything aside from dependent types. But by the way, when you do like everything, when you have like all four, when you have the full table, when you have calculus of construction, you are not really adding new stuff there. You are actually removing.
That sounds unintuitive to say the least.
Yeah, but you know why? Because you will have abstractions and
Yeah, you're making
applications.
restrictions.
Oh, because everything can be
Because
anything.
yes, that's
Hmm.
why we can collapse
Wow.
them.
That moment when something immediately got intuitive. Wow.
They are very, how can I say? Like homogeneous, not homogeneous.
It's kind of the word is not homogeneous is not the correct word,
Yeah,
but the meaning in my head is that.
Uniform.
Yes.
Uniform? Yeah, maybe uniform.
Yes. Okay, that's
So let's think.
Mhm. Anyway,
Right.
let's continue here. So T variable, what is the
We
kind of
already
that?
did the variable.
Yeah, right.
Oh, it's out of
Just
order.
kind.
Sorry.
Yeah. Now it's the for all.
Okay, so what is the type of a for all?
We
It
know the
should
final
be.
result.
Yeah, it's a star. But I'm thinking there is only one thing there you need to check, right? Which is the ident type, I think.
Yes, you need to check it. Why?
Because you need to see if that thing so like, okay, like there'll be we kind check that thing, and that thing needs to be let me think. So if that thing is a star, okay, wait. Don't we need to add to the environment the variable?
Yes.
Yes. Yes.
Yes, okay, so I'm getting it.
Um, we do need to do that. So
But okay, after we add to the environment to check, what should we check for?
here.
Yes, this. Okay, so we send the thing we want with the variable with the kind you're passing there. Is that correct? I think that is.
Wait, I didn't get the last part. Just a
Like
moment.
you have the identifier and the kind, and then that will be the kind.
I'm
Like that's
confused.
the key and value you need to
For
put
the
in the
new
map.
environment, right?
Yes, and then you have the body of the thing, which is the ident type, I think, right?
Uh-huh.
And then with that, you need to evolve with this new env. Is that correct?
Yeah, like that's
Okay,
your
yeah, okay.
result type there, right?
You're gonna have to
Yeah.
repeat that just a moment.
Well,
Yeah,
your
because
kind
you just want to
indentation.
replace the things with the new thing.
Yeah, but then we did that. But do we need to check something if kind indent is something
Well,
specific?
it can still be a star or an arrow.
Can it?
Yeah, I'm thinking.
Well, type system wise, yes.
Yeah.
But in reality, right? In
Well, if it's
practice.
a star, it's just a star. But what about the arrow? From what you said, I don't think it does, but I don't know why. Let me see. Because that would that represent a term?
The heck?
Okay, that if it's an arrow, that would mean I think it's useful if you make an analogy with it on the kind.
Mageta. For all is representing what?
What do you mean?
Uh, like for all, it's in the universes or sorts of types, right? So it
Yes.
is describing the sort below. So it is describing terms. Which term for all is representing?
Oh, okay. I see. So it cannot represent a arrow because you're not escaping this universe, right? It's only one that you're talking about.
I don't know about escaping,
Yeah,
but
if an arrow is can has a possibility of escaping.
uh, 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 yeah, I
Wait.
think that's not a problem. At
Okay.
least if we had dependent types, it could happen.
Wait, can you repeat for me?
Wait, let me just like try to finish this for Mageta.
Okay.
Mageta, for all is
Mhm.
representing a type abstraction, right?
Yes.
So what is the return of a type abstraction? Right? What is the body of a type abstraction?
What is the body of a
The
type
body of
abstraction?
a
Is
type of the section.
wait. The question is what is the body of an E-type abstraction?
Yeah.
That's an expression.
Yeah, it's the
Yeah.
thing it's
So
enclosing, right?
yeah, so it's the expression, right? The body of a
Mhm.
type of abstraction is an expression. It returns that. So its return needs to be a star, right?
Yes, this
So
needs
we
to be a
need
Oh,
to
I
star.
see.
check for that.
So it should. Okay, I get
But
it.
it could be an arrow if we had dependent types, right? Because then it could return
Okay,
also.
wait.
No,
Let's.
no,
Oh,
actually,
damn it.
no, that
Okay, I get
no,
it. I think
no.
I get it.
Forget about that. Forget about that's wrong. That's wrong. The type abstraction will never return a type. Some other construct will do that.
Uh, People, let's
Okay.
rewind a little bit. because
All right, let's think. So it cannot be a star. No, sorry. It needs to be a star.
Yes.
wait,
I still don't get why not the arrow there.
wait, Nagata, can you start from a little bit before that so I can jump
Okay,
in?
let's revamp everything. Yeah.
Yeah,
So we add to the environment because we have an enclosing body. You agree with that, right?
we
On
have a.
the
You're
for
talking
all.
about the for all, right?
Yeah, for all encloses another thing on the ident type,
Yeah, we
right?
need to add the we need to add that identifier with that specific kind to a context before kind checking the ident type. I agree
Yeah.
with that.
Yes. So we add the kind with that identifier to the context.
Yeah,
Then we check the kind check with environment again. Uh, okay, you're just adding there.
yeah,
And then after that, there's only two possibilities. The first one is being a star,
which
the
is
kind
correct, right?
indent, which is fine. Like the result, we know it should be a star. I'm just questioning about Nathan said that it cannot be an arrow. Like this kind ident cannot be an arrow. And I'm just trying to understand why.
Because its return type, it's typing its body, right? And its body, it's an expression.
It's just a symbol expression. Okay. Okay, but here's the question then. In which case would it be valid for it to be an arrow?
Dependent
Okay.
types.
Yeah. Kind of. I got confused there. I said that independent types that would be possible, and that's not exactly it. Independent types, you will have a construct, probably like in the type part, right? That will accept like an expression, right? Wait.
Oh, I see. I think I see.
Can
Because
can
we're
you
not
No.
explain?
being.
Actually, no. Actually, we already have. Like what we actually what we want is the type abstraction. Like the type abstraction is something that is receiving a type, as type abstraction is, but its body it's a type, and then it can be an error, right?
That I agree. I understood that. Can you explain, Magit?
So I think like it's only valid to be an arrow if we're trying to do something like right the e-type application or abstraction.
Yeah, like returning a type in the body, right?
Yeah.
The long story short that I got, like the way that I'm thinking is that T for all represents in the type world represents the E-type abstraction, which is an expression, and that thing always returns an expression, which means that we cannot have an arrow k as the result.
Yes. So even if we don't check, that's kind of not a problem regarding the result of for all, but we need to check to see first of all if there is like unbounded, like type variables, right?
Yeah.
Uh-huh.
And yeah, that's why we.
I need to digest more of this because I'm kind of being
Yeah,
pragmatic,
me too.
but
Pragmatic.
I'm totally being pragmatic because
Yeah,
I
Pragmatic, just an
convince
agree.
euphemism
myself.
for saying I'm not understanding and just typing. That's
No,
it.
but I convinced myself after some of Nathan's explanations that every single time you're talking about an expression, there needs to be star.
I can be
Yeah.
tricking you, right? I could just be wrong.
No, but
Yeah,
that makes
nothing
sense.
just
That you made it make sense in my mind.
I could be tricking you, man.
No, okay, maybe you are, but from what you said
Yeah,
and my
but
experience
I
with the
think it's
kinds and
useful.
types,
I think it's useful when you think where does an arrow come from? It comes from a function, right? But we're not talking about a normal function. We're talking about the T abstraction, which is enclosing a function.
yeah, you're talking about a function in a level of I'm gonna I'm gonna receive a type and return a type, which is something that we don't have in this world.
Yes.
So
So
then it makes sense. Like this is another pragmatic way, in my opinion, because the way that Nathan says it sounds more like correct instead of following this algorithm that I'm talking about. If you're talking about expressions, like I like it's not Nathan tricking me. After I thought about it, yes, expressions they are always a star. That's
That's
it.
called Stockholm syndrome,
yeah,
lembra?
no, dude. But like, think about like types of propositions. The thing, the talk. There's every expression is only assumed to be one type, right? You always reduce the thing to one type.
Yeah.
So I don't think of a class of types or anything. It's always one type.
And if it is only one type, it's not a type to a type or a type to a type
Yes,
to a type.
exactly.
This needs to be
So
always a star, which is great because
yeah,
it's a
but
sign that I'm understanding something.
can you think of a proposition that would lead into
An arrow.
the arrow? Yes,
Yes.
the arrow.
Dependent types.
No, yeah, I was
No,
wrong about that.
No,
I was
but
wrong
I
about that.
even though
yeah,
you
I
said
wouldn't
that
say
you were
that,
wrong,
but
for me it still makes sense.
Yeah, kind of. What I mean is, independent types, you have something that returns a type, right?
Yeah, but it's an
Then that
expression.
type, that's the thing. I wouldn't say that. I don't think that it is.
Wait, how can you have a
I'm not
dependent
sure.
type that... I'm confused. How can you have a dependent
It's
type
a
that...
type. No, no, it's not an expression. It's a type. Because see, you want a type that depends on a term. So it is a type. It's not an expression.
It is a type and an expression.
Yeah.
Oh! Okay, yeah, so no. So that dependent types would enter in here.
Yeah, together with like the abstraction. It's something that
Ah.
returns a type, right?
mhm.
Oh,
Doesn't matter
okay.
what it is
Okay.
receiving, but its body could be arrow then.
Yeah, so I don't know which how can you have instead of a star you have an arrow then
Well, in the body of a type abstraction.
in the body of a type abstraction. You mean here?
No, no, no. I mean the abstraction.
Oh, T abstraction.
Yeah.
No, but you cannot end with
Well,
this
no,
in a for
okay,
all.
but there's no.
No,
Wait,
no. Yeah,
what?
that's not the for all. That's what I'm saying.
But that's
Like
his question.
it is a no, no.
No, but
Okay.
yeah, but the question is the for all is not doing, is not constructing anything, right? It's just
Yeah, the
returning a
for
single
all.
type, which represents a single expression.
Yeah,
Yeah, the for all will never return an error.
an arrow.
So yeah,
I can't think out of a case that's possible. Ah, okay.
the black swan fallacy. I cannot think. No, I had never seen, so it's true.
No, I'm not saying that.
No, I know,
I'm
but I'm
totally
just
sure
saying
that there is a color in
this
the
could be
universe that I
very
cannot
wrong.
imagine, man.
But anyway, like just go.
So if it is a star,
Then
then
it's a star,
it's a star.
By the way,
and if it's an arrow, it's
I would
fail.
check that on the code Nugget because that part I would say it's the one I remember the least. The least.
No, nice. So we're all blind here.
Like a blind follow another
And then we
blind.
discover we're discussing this all this time, and you were wrong.
Yeah, so take a look on that.
Let me see.
For
Oh,
all.
better yet, look at the paper.
Oh yeah, I didn't finish reading that.
But they have like the tables there.
Mm-hmm. Wait, for all should return this. Yeah, it should be like universe above this one, higher than the previous, or something like this. Like, think of a .NETized way to say this. I'll think of how to translate all these error messages
Man,
to corporate
Yeah,
culture.
Lemus, that it's the cases that you could even draw an exception. That shouldn't happen. Like if our code is correct, the user could not do that. No,
okay.
no, I'm not saying for you to do that. I'm just saying like it's supposed to not happen.
Okay.
Impossible. Yeah.
Okay, so next one on the line is the T application.
Yes,
Yeah, those
application.
ones are like
Yeah,
easier
this
than
one is easy, I
they
think.
look.
Okay,
Yeah.
so let's suppose that you have a T application. So
This one needs an arrow.
Do
that
the abstraction
that is
first,
when you
man.
have a type operator and you are fulfilling something with it, right?
Yeah.
Yeah.
So
Okay.
this one, the abs, I think that garbage needs to be an arrow. Is that right, Nata?
Uh, wait, what was your question?
That in this, the application now you need the function to be an arrow.
Yes.
The ABS.
Yes, I agree.
The abstraction, right?
Yeah.
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 Okay.
So it's an arrow,
And
okay.
what do we do? Okay. And what do we do with that? We need to. Okay, there's something else, right? We need to check.
You need to check
You need
if
to check if the points of the arrows are the same, right?
wait. Wait. I don't,
with
Matan,
the
don't say.
arguments.
I think Magetta and we are understanding enough.
Well, I don't know, man. Not sure about that. But here's I'm thinking we need to check if the argument is equals to the points of the arrow kind, right?
This,
Oh, but wait, Lemos. Okay, yes. If
Lemos,
K1,
if,
then yeah, okay. I think if it doesn't, then it's a left, right?
yes,
Shouldn't happen.
yes.
Wait, why are we matching the kind arg then?
Oh yeah, you could just do.
Oh yeah, this guy doesn't matter. Yeah, this is surprising. I was expecting to be
This is very
worse.
intuitive, actually. Yeah.
Yeah,
Like
now that we
that's
are understanding, eh?
that's the fun thing we did. We are basically doing the simply typed lambda calculus at the type level. Like if you take a look on the functions,
Yes,
they are
yes,
like,
Yeah, it's the
yes.
same thing. Yeah.
well, they are the same thing for now because we need to go back and change some stuff there.
Okay. Yeah, no, we're gonna. No, it's already wrong. This is not gonna compile anymore because we removed the bounded types
Ah,
from here,
yes. Mhm.
so everything is now wrong potentially.
Yeah.
Okay, so kinds don't match. Uh,
Um,
we're gonna have a session just to make error messages better.
Mary-
So I'm gonna make just like this for now.
I'll study how they get formatted in .NET. Don't worry.
So
So
Man,
if it is a
no,
star
Magenta, why don't you study how they are setting Elm?
in
That would
Elm,
be, yeah, in Elm. That would be a whole new level for you and the language.
why?
Well, because they have the
Why you
best
lobbying
errors
for Elm,
ever.
Nathan? Why you lobbying for Elm? Why is that? Is it because of the browser?
yeah, of course it
Yeah,
is. You have any
Is
questions?
it?
not, no, not really. They are the ones that do the best error message, man.
Okay, I'll take a look.
Let me send you a link. Well, Unison is pretty fucking good, and I think they are inspiring now. But man, if you read
Okay, now
this,
this one I'm not sure. Oh, okay. This is just returns an error, right? We just wraps the stuff.
I think
Oh,
so.
dude, this is the same thing. Yeah. So we need to add the stuff to the environment and return the thing based on the type. Is that right?
Wait, can you repeat that?
So yeah, we need to add the kind of the grep on the environment.
We need to add the kind of this grab
Yes,
to
the
the
label
environment.
kind, and with that we check the type, right?
Wait, we
Oh,
add.
but wait, yeah, the type needs to be evaluated again. Evaluated, no, checked, right? On the
Yes.
kind check.
So this is abs.
call it kind context.
Yeah,
Kind,
we have kind
yes, we do.
context coming from the environment.
Oh,
Yeah,
up there, right?
Yeah.
and then the result should be the arrow, like from the parameter thing
Wait. I have a question.
to the return
I
thing.
have a question. So this is the abstraction is the type operator. Is that correct?
Yeah.
Okay. So the label is just, well, whatever. Like it's a label that you're gonna replace later.
Mm-hmm.
Then the kind is actually the kind of the entire thing, and the type is the type of the label.
Wait, what is kind indent there?
Kind ident.
Kind ident where?
On
Oh no,
the
this is
case.
Oh
wrong.
no, it's just copied.
Yeah, I just
Yeah.
copy pasted from below, from
Yeah,
above.
but I don't think you even need to match
No,
that,
but I
right?
want to understand what you're doing. So this is when you have something. Oops. When you have something like this that do whatever, and the return is a type, correct?
The
This has
output
some
also.
specific kind, and this has a type.
Yeah.
Okay. So this, what we need to do?
Wait.
We
Okay,
need to
yeah,
add the
that's right.
label with that kind to the context. That makes sense.
Mm-hmm.
Then we need to kind check the type of this.
The body, right?
Wait, the type prime is the body?
Yes, that's the type of the expression it's
Yeah, it's
enclosing.
because those names, right?
Yeah, the names are horrible.
Wait, so the kind is the kind of this. And this has a type.
I have no idea what we are writing.
No, I'm
But
asking.
that's look wrong.
Yeah, this type is it's representing the type for the whatever. Yes.
Okay, and the kind is the kind of the entire thing or the kind of this, of the X, of the label?
It's a label. That's why you're adding it to the environment.
Okay, so what we need to do, we pick the
Then we
label
don't
with
even
its
need to
kind,
match.
add
Yeah,
to the environment, pick the
yeah,
type, which is the
yeah.
type of the
Kind
body,
check
kind
the
check
type.
that.
Dude, change that name, man. The type, please. That's very
Yeah.
confusing.
What are we
Do
using
body.
in the application? Oh, you're using expression.
Yeah, body. Do body. It's much better.
Okay,
Body type, something like
yeah,
this.
body type is okay. Body.
Yeah, that's tricky because it's not the type of the body, right? It's a body that happens to be a type.
Yeah.
That sucks, but okay. So, then we do body type.
And then you just pack in the arrow, right? Because it's a
Yeah,
abstraction.
change the name of kind ABS because it doesn't make sense.
Yeah, it's the body, right? That you're checking.
Yeah, the body kind, right?
Yeah, the kind ABS would be what you will generate. Is the arrow.
Yes.
Okay, I'm back.
Oh.
Okay.
We were talking like okay.
No. It's because today is a messy day here. People are entering my room all the time.
So just change the kind ABS
Lemos
because
cave.
Wait. I
remove
got
his
until
lines,
this
by the way.
point.
Yeah, just remove his name because now it's not really the abstraction, right? It's the body
Okay,
only.
that makes sense.
And then remove this because we don't need to match.
Why don't we need to match?
Well, it's already the result, right? We're just building the body, the arrow kind. So it's arrow kind, and then we pick the kind of the that you pass there with the kind body. Yeah. Oh man. Yeah, okay.
By the way, do a
I
comparison
feel like
between that and the type checking.
yeah, remove the line 6 by the way down.
6 down here. We also need to make this.
I feel like I grew. I feel like I like my IQ points grew like by 4. I don't know.
Okay, we need to actually pay attention to the bound variables because now type checking is
Oh
wrong.
yeah. Try
Well, we
compiling,
need
but I
to
think
review
everything
everything.
will be. Yeah. Yeah, there's interrogations there.
We have a bunch
Yeah,
of
but
warnings, which is fine. Then, oh no, but the typer is it couldn't be parsed, so that's why it's not appearing all the errors. So
yeah, but it's
79.
fine.
So 79
Okay, that's a whole other
here.
garbage. Yes.
Okay, so now
What
that
were
we
you
have
doing?
kind checking, we can just add it. Like, is that correct? We just add it here.
I have no idea what we were doing there.
We
What
were
is that?
checking
Yeah,
if
that was
Type
the
the
type.
application.
Yeah.
Oh.
So that's will be tricky because we got the e-type application. So we have to pick the kind of the argument, right?
wait.
Wait.
So we need to check if the kind of this T for all is the same kind as.
Not the kind of the T for all. The kind of the
Compare
T
with the
for all
thing with
parameter.
compare the thing with Nathan's Coldman first.
Oh.
I would say for you guys to take a look there because it's like really close and it will
Yeah,
have a
just go
look.
to the kind check. Let's see if it's similar. Or we did some poo poo.
Oh, you mean the kind check here?
Yeah, I don't know. Like a two for all, we discover it's all wrong and it's actually an
No.
error.
Like it doesn't have to do with any other part in the code. You guys have already everything there, and it's like pretty
Oh
fucking
yeah,
close.
let's just see and then we go explaining. Let's see. So put it side to side.
Oh,
Yeah, put on the scratch buffer.
No, I can have both. Wait, not this
No,
one.
like Nathan's code, just making a scratch.
Oh,
Whatever.
Fancy
Natan's
max
code.
skills.
I don't have. Oh wait, let me
Uh,
unpause the recording.
Just run
So.
Tuareg mode there, so we have the highlighting.
Yeah, without highlighting, that's pretty hard.
Where's True
Kind
Sugar, man?
check. Is that the
Where's True
name?
Sugar? Oh, I think,
We don't have kind checking here.
kind of, maybe?
Kind of. Is that how you do
Yes,
your
kind
camel?
of.
That's not a language thing.
Here. No, that is a
Just,
convention.
dude,
Of course
please,
it is.
please,
No,
please,
it is not.
It is
Tuareg
a
mode,
name.
man,
Of
please.
course it is a name convention, man.
Not because I'm using OCaml. What the OCaml people use to do kind of.
No, he's talking about the underscore, isn't he?
Of course I am, Maggot.
Oh,
Yeah,
okay.
Nathan is just
Maggot.
No, but that's
Meta X.
uh,
Please do that, otherwise he'll go crazy with his blank test.
Meta X.
Tuareg, like the African Tuaregs.
Two. I don't know how to write that. Oh, here.
Tuareg, yeah, mode. Tuareg mode.
Here.
Tuareg open mode.
Just Tuareg mode. I don't know what that open shit is.
Oh, Tuareg Menhir mode. Oh,
Yeah, dude, they're first
oh,
warriors from the
it's
desert.
because like for
People,
Opan and other
let's
stuff, you have
finish this.
specific files.
I was reading a book on their lineage on the Berber people and the Tuareg. That's pretty cool. Anyway, that's
Okay, so let's suppose for a moment that. Wait, kind of? No, this is not what we want. We don't want kind of.
no. This is the kind check with environment. It's the same shit, man.
No, it is, but aren't we confident enough? I just want to finish type checking and see if it compiles.
Okay, so look for the function Nathan is doing the type check with environment. Look down there. Go all the way down. It must be the last one probably. Go up. What is this?
Yeah,
I
there's a
think
lot
this.
of shit
I
there.
think this is the one. I think this is the one though.
Go up. Look at the name.
Type
Type
of.
off. Okay, it's probably this.
So we need the T for all. Do we have that in here? T arrow, T unit.
Wait, what do you mean by T4L?
You are on E-type application.
We are on.
Oh.
Oh yeah, here. Oh here. To do. The situation is
Nice.
the same as application 1. I need to reduce my function before matching to check for a T for all.
Ignore this for now, man.
Okay. So the first thing that you do, you type check the function, which is in our case we are calling expression for some reason.
Mm-hmm.
Then you
Yeah.
reduce that. I don't know what reduce
Ignore
type
that.
is.
Ignore that part.
Okay. Then you pick the argument kind that. Oh, okay. So you pick the thing that you are applying to the function. You kind check
Yes.
that.
Yes. Okay, that's cool. Yeah, so kind check, blah blah.
So this is gonna be.
But you guys did that.
We
Did
did?
it?
Where?
Like
Yeah.
kind check with environment, env, then ident type. But it's not ident type, right?
Oh yeah, we were doing down there. Yes, this. Oh yeah, man. It was with the interrogations. That's right.
Oh wait.
Too.
So we need to. Why do we need to? Wait. Let me try to answer myself. So why do we need to kind check the argument?
Well,
Why
need
do
to.
we need to type check the argument?
We have the kind for all that is being abstracted on the type application. We need to see if they're the same. If they're not, then there's something wrong.
Oh. It's kind of
It's
interesting.
like meta level, dude.
We are looking at the same thing from two different lenses.
Yes, that's like a meta level for.
Talking about, dude.
It's like ontology.
So
Okay.
if this is equal, then we just apply substitution.
Yes, I think so. Let me see.
Let's see, Nathan's.
Yeah, he makes substitution. Wait.
Yeah, I think that's it. Look, if the
Yeah,
argument
okay.
kind is equal to the parameter kind.
But what is that? Why is it doing that on the reduced function type? What is that reduced function type, by the way?
Okay, you see that reduction is an abstraction, right?
Yes.
Yeah.
Well, yeah. Well, I mean, you see that function is an expression, right? So that
Yes.
expression could be a variable, right?
Oh, okay. Mm-hmm.
Which
And
expression you're talking about?
function,
The yeah.
Oh, here.
function, variable, right? And if it is a variable, it was bounded somewhere up there, right?
Mm-hmm.
And the annotation of that variable could be a type application, right?
Wait.
The annotation of that variable could be a type application.
Can you can you provide an example, Nathan?
I'm not sure I got it.
Yeah. Oh, I have there somewhere. Go up there. I have ID something. If you go up there, you find. Go up. Yeah, there. I guess.
Wait, here.
Yeah, there. So you see that I
Which
have the
line?
type of
Sorry.
man the comments.
Oh, here.
Oh,
Okay.
okay. Type
So
A ID type. Okay. Oh, dude, that's the same thing. Okay, that's the same thing we were doing on the.
what
That's
is
the
the type of
example.
ID
Yeah.
inside the context of the f function, right?
What is the type of this you say?
Yeah.
Yeah, it's the whole type up there, the line 2. That's the same example I gave on the F star thing.
Wait. The type of ID is int to int, right? Am I
Uh,
going crazy?
well, it is an
Yeah, a
A.
bit crazy.
Okay.
Yeah,
Well,
Wait.
well, not crazy really, but
it takes
Wait, what is the type of ID then? Can somebody help me?
well, it's there, right?
it is
It's
ID type that abstracts on A that takes A to A.
yeah. So it's a ID
Applying
type.
integer.
Oh, the type of ID
So
is a
it's
type
the thing we
application.
it's the thing we
Yes.
tried on Haskell.
Okay, fuck. Okay.
See, that's why we need to do substitution. That it's the reduce, right? It's a better. Well, it's a normalization types instead of on.
Oh, so that then you don't have to mess around with this sort of mess.
Yeah, because if
Ah.
we want to check its format, right, we need to normalize. Like, we need to normalize first.
Oh man, I'm thinking here. It would be funny if after doing all of this, we just added null to the language.
We could.
I don't think we could. The way that we are doing, and especially
You
now that we have
certainly
a bunch
can.
of stuff
Do you
based
know
on the
what we
idea.
could do? We could add never. So it's a type
Oh, okay.
that
Like a
cannot receive
false,
any value, right?
like false in. I think Coq has that as well, like an empty set false, like this.
Yeah, and we don't even need to add a special type for it. We could use like something like for our a, right? That it's a type that cannot be constructed, like it's inhabited. And then we could just like disallow the thing regarding annotate parameters with things that are stars. If it's allowed that, then we can annotate the function with never. It will not fail the type checking, but then you cannot pass any value to that function. And after that,
Awesome.
you do a type that is a predicate.
Yeah, that feels like trolling. You have a function that
Yes.
needs to
No,
receive
no,
null. I'm not gonna allow
no,
any
no,
value to
no,
exist.
no. That's not trolling because then if you add something that it's better with dependent types, but basically you will add a type that it will either return one type or the other. This other could be never, right? So depending on the predicate, it could receive of something of one type or it could receive nothing. You see? The only thing is that that predicate could not be an expression because we don't have dependent types yet, right?
Wait, I got lost in the middle of the thing.
Yet.
You
Well,
have a
look
type.
at the way he says yet.
You have a type called if, okay? And if takes a predicate and two types, right? The two types are the like then and else, right?
It
Yeah.
takes two
So
types or two expressions.
it takes okay.
One.
You have a
Well,
type if, and it takes three things, right? A
Yeah.
predicate that I will talk nothing about that, and the then and the else, right?
Yeah.
The then and the else they are types.
Yes.
Yeah,
right?
like the example I
And
gave on bool and string, right?
Yeah. Go,
so
Nathan. Go.
suppose the else branch is the type never.
Okay.
Okay.
So depending on the predicate,
Oh
then
man,
you can accept the type, right?
that's literally
If
meaning.
not, you cannot accept nothing. Then if the predicate could be an expression, then we have something like refinement types, right?
Mm-hmm.
We check,
Wait,
oh,
wait, wait,
if
wait. Go
this,
back, go back. I got lost. I know exactly where I got lost. I got lost when you said the else branch can have the type never.
yes,
What
Yeah, I
does that
think.
mean?
it's a type that
Oh man.
is inhabited. Like it's a
Yeah,
type
it's the
that doesn't
empty.
represent a value. We already
Uh,
have them.
let me
Like
send it
if
here.
you mount for our A, how can you pass a value to that? You cannot. You cannot construct a term that matches that type. It's inhabited, right?
Yeah. Oh man, there's a good example on F star.
Wait, wait.
Just
You
a
said
second.
that it is a type. So the case is that we have a type that cannot be representable in a value. Is that it?
Is this what you're talking about, Tata?
Well, you have a type that you could not possibly make a term to match that type.
Yes. Okay. I understand. I understood that. Go on.
So yeah, then you have this if, right? The else will be a never, depending on the predicate. If the predicate is an expression, then we have a fucking powerful language, right? The first thing is that it's dependent, right? It is receiving expressions and returning types.
Mm-hmm.
And the second one is that given the predicate, we could then say if the thing will receive something as argument or not.
That's actually a cool idea.
And that's using the never. We could use a normal type and then the function
I don't
either
understand.
exists.
I'm not understanding why the never is
Can
necessary
you
for this.
look?
What you said.
Can you look at the example I
It's
sent
not
to see?
necessarily, it's just one use case of this if type, right?
No, no, but everything that you just said about having, oh, we have an if, then the then branch and the else branch they return types, and then you can have if you have the predicate being an expression, then you have dependent types. All of that makes sense. What I'm not understanding is why did this discussion started talking about never or null?
Simulating. No.
No, but I don't see why
It's
we
not
need to.
simul.
Why are you talking? I don't understand why Nathan brought this for talking about nulls. That's what I'm saying. Nothing
Because
that he
it's
just said
No, that I don't know.
talks about nulls in my opinion.
I'm just saying, like, it would be funny adding null after all of this,
No,
and
no,
then
no,
we
it
started the
would, but
discussion.
I'm
Oh,
not
can't we?
understanding. I'm trying to understand why Nathan decided to use this example.
okay. I think it's funny because then you have a function that it's valid, but it cannot receive anything. I'm not saying that's new. I just like remember that that would also be funny, right?
Wait, you're saying that it cannot receive anything.
Yeah, something
Yeah,
that
the
has the type
never.
never.
Yeah.
And then I expanded on the if type
Like,
because it would be more interesting.
Oh, okay. So
yeah.
if you have a type that doesn't have a value on the real world, that means that you cannot use that function.
Yeah.
Ah,
Look at the example on the F star
oh
tutorial.
my
Not the.
god, man. What a circle.
Send the link
Ah,
here.
my mind is melting.
So the type never in that case would be sort of the false, right?
Wait, let me open something to get that thing that you sent.
Never.
Okay,
That's
so
for
Oh.
termination.
you were talking about pro-oriented programming. What?
No, that's
Man,
termination. You can ignore
did
that. But
you? I
there's
don't
that
think you
type.
sent it the correct link, Magenta.
Let me see. F star tutorial.
Where is the
Oh,
thing that you're
this
talking
thing
about?
is JavaScript. Like you click on stuff and it doesn't.
Yeah, which one should I click then?
Wait. Yeah, proofs of termination.
Oh, okay.
Proofs.
Yeah,
Oh,
let me
here.
copy the. Yes. Did you find it?
Okay, so let
Listen.
rec loop x
This one.
unit cons false. What the heck is that?
Yeah, so that's basically saying, okay, I received.
And I
And
lost your audio.
oops. Hello.
Yeah. Now it's back.
Yeah, but look at the type. It's false. So is
Yes.
this false? The thing you were talking about, Nita?
I'm not sure, man.
Because I know they use this false to represent. It's not like the Boolean false. It's just to okay, this proposition is false.
Yeah.
Man, does this make any sense? It's a function that receives a First, it's
No,
recursive.
dude, this function doesn't work.
Oh,
They're
okay.
just using this as an example to say, okay, this function is not computable because it never ends. So that's how they're checking termination.
I think it might be, man.
Let's
Anyway,
see here.
can we go back to Earth because this is already getting too confusing for me. So let's go back and the question is, do we need this reduce
You
reduction?
do.
You do. Oh fuck.
Not now, not now. Don't mess with that now, man.
Okay.
Just forget
So,
about the
but
cloud.
just for context, we are reducing stuff because we don't want to mess around with having type applications in the type signatures, right?
Ah,
Of the
no,
abstractions.
no. It's
No.
because we have that, then we need to deal with them.
Wait. I don't think I. Wait. The type of ID is type application, correct?
Wait. Can you go to U type check in the abstraction?
Here you see, you mean?
Yeah. So you see that I have a parameter type, right?
Yeah.
What I'm doing with the parameter type?
You are checking its kind, checking
Am
if
I?
it. Yeah.
Oh yeah, I am.
So you are checking its kind. Then if it isn't star, which it needs to be because it's an E abstraction. Uh, if it's key star, just a star, you do something. If it's an error, you do fail. That's it.
Okay.
Then
And
if it's a star, you add that to the environment. Then you type check the body, and then you create a T arrow, and that's it.
okay. So you see that in like I never like changed the structure of parameter type. The only thing I did was passing around to the environment and to using to get the kind, right? So checking if I have like unbounded variables and such, right?
Yeah. Okay.
So I never changed the structure. So it could be a type application, right?
It could be a type application. It could.
I'm not normalizing, am I?
No, you're not normalizing.
That's why we need to normalize there, because we are not normalizing here.
Why do we need to normalize anyway? That's my question.
Wow, because I'm matching to see if it's something, right?
Oh, wait. Oh, I see. It's because, oh, I want to see if this is an integer, but what I have is an application that potentially
Yeah.
returns an integer or something like
Yes,
that.
yes, exactly.
Ah, okay. So we do need to reduce it, but how can we get around that for now?
Well, we just don't. Oh, that's easy,
Okay,
right?
so we cannot type check. Uh,
Man, like the program will compile and work and shit. We just cannot like make this case of putting an application, a parameter thing for now because they will say it will not type check, right?
oh wait,
But
now I am confused.
okay,
Um, the E,
so
this is the E application, right?
okay, the application, right?
Yeah,
Yeah.
so we were on on the wrong pattern match, but okay.
So yeah,
So
what
it's this one.
happens is that if you don't reduce, right?
Oh, we are just missing. If it's not the correct kind, who cares?
Yeah, it will just say, oh, that's not an error, right?
Yeah, okay. So can we do that with the E-type application, E-type abstraction for now? Do they need yeah, the E-type application it needs reduction like normalization.
Because it also needs to see if it's a for all, right?
Yeah. So at the moment, okay, so we're just gonna not care again. So I'm gonna
Yeah,
remove
we
this
can.
if.
Yeah, I. Huh?
Yeah.
No, wait, I don't know what you are doing there. We
I'm
do
just
know
removing the
those
kind
things.
checking
Why?
because we don't have this.
Uh, I can't see how you are. Man, those things don't relate.
Wait, now I am confused. Can you if you don't have the reduce function type, how can we gonna do this pattern matching?
Well, we are doing that for all. It will just fail. Go to the left case in some specific cases.
I'm confused. Totally.
Okay, so the kind check that you just comment, it's basically, well, checking the kind, right, of the type that is the argument and the parameter of my for all, right? So that works just fine. What is not working in our current code? What doesn't work is, what if the
What if
type,
you want to compare two kinds that are the same, but one is the application not reduced?
no, that has nothing to do with kind comparison.
Okay.
That has to do with the pattern matching. So you see function type. What
Yes.
if function type is a type application? It could potentially be a for all, right?
Yes.
Those cases in which they are type applications that happens to result in a for all, they will fail for now. So, and I mean fail at our type check will disallow them, right? So that's not even a problem. We'll just discard more programs that we want. We are not allowing any incorrect program.
Wait, so
We are
let
just,
me repeat what
yeah,
you said. So by not normalizing stuff, if we have a function that actually is some sort of like a type application, then those programs will fail.
yeah. So they are programs that are right, but the type system will discard.
Okay. Okay. I'm convinced. That makes sense.
Yeah, just do a to-do of, oh, normalize this type here.
Um, I'm gonna make an issue, man, on GitHub about this.
Yeah, but you need to put like, where is it, right?
So we need it. So there's a to do here and a to do on the other one. E application, I guess.
And by the way, that kind of stuff
E application.
is the kind of stuff that it's really annoying. Because when we implement some things that I'm pretty sure we will want, like type alias, because without type alias, the languages are too verbose. When we do that, we will do that kind of normalizations everywhere. Because every time we are like
Yeah. That
treating
makes sense.
a type in a not uniform way, we need to normalize and then affirm something about it, right?
Yeah, we need to normalize in order to get the real thing instead of the alias.
Yes.
Oh, want to
And
see
that
harder than. Okay.
and I thought that was literally harder than implementing the whole like system itself, like implementing the ad hoc type alias. Man.
And it is? Is it?
Well, I think when I mean I thought, I mean after I finished it, so that was my final impression.
It is harder to make aliases than all of this.
I think it is because well, the other things you are seeing the paper, right? So you can check the things, but
Hmm.
the type alias is ad hoc, so you have to just think about it and see if you cover all the cases. So
Oh yeah, that
Where
sucks.
did you send the paper, by the way, Nata?
On the
Maybe you
chat.
sent which one? That's the
The
problem.
one that we are used for this call.
Let's
Okay,
see.
so let's finish this. So if we have a type check with environment, considering that if the expression that is this, considering that this potentially will be a type application, um, then we are done because then we are not gonna we need to do reduction and we don't have that. So let's suppose aside from that we verify if the kind that we are expecting from for the for all is the same as the one that we are providing in the E-type application. If the kinds are equal, we just call substitution. If they are different, we should return left, I guess. Is that right, Nathan?
I guess so. You can check with the type there, right? Oh yeah, with the type I mean the other program.
Uh, you just fail with to do.
Yeah, man, like I was rushing to the thing.
um,
Speedrunner.
expected type for type application.
We
Oh
could
my
do
god.
like a speed run, right? Like who does the like we
Expected
pick
kind.
Nathan does Nekoma. I guess Nathan will win.
No, of course Nathan will win.
I guess that the Haskell guy that implements at least a few times will win for sure.
But that's my problem. I'm doing this for the first time.
No,
No,
yeah,
but like
but
if we get good, we could do a marathon, like a competition. Who makes it faster?
Who makes the cube faster?
oh, that would be nice.
Oh, I love that, dude. Oh man, let's totally make it an event, please.
But at our current state, we could
No
spend
man,
the week and then still don't do it.
no man. I'm gonna make a event right now for, let's see, 4 months from now.
I doubt it. I doubt it totally, but okay. I'm gonna
On
have
the
to read the
calendar,
paper
though.
though that Nathan sent because now I'm really feeling that I need to read it to properly keep up. But I don't even know if 4 months is gonna be enough, especially because we're not gonna stop after having the cube. So expected
Just,
kind for
dude,
type
before
application.
going to bed every day, you should memorize the algorithm every day.
Expected kind for type application does not match.
You write in a paper the algorithm 3 times every day
Holy
on a sheet
shit.
of paper. In 4 months, you can memorize every single comma.
Holy shit.
Okay. So which other things we need type checking, people?
What about abstraction, right?
Oh, this is using the bounded type, so we need to change this one. Uh, okay, so here. So what you're doing in the E-type abstraction, you get the things, then you add the kind to the environment, and then you just call it. Wait. You are.
Oh wait, I
It's
said
kind of.
type abstraction.
Yeah.
Yeah, but that's already done, right? Correct?
No, it's not done. It's not done.
Oh, okay, we forgot about the end.
So let's see which day would be the Lambda Cube marathon.
Oh man.
I'm scheduling. I'm serious. I'm
Man,
scheduling.
if you do that, I will rush for dependent types, dude.
Insert. We need to insert to the map
Let's see. We are in
a label.
October, so oh, we could do like like before Christmas, like in December. That would be cool.
Wait.
Like a Saturday or a Friday night. Which one do you prefer?
I prefer the Friday night.
What about Jonathan? Friday night?
I have a question, Anta,
Mhm.
about this code. Hi. My mind. How much time we are here? Let's try to do 3 hours. So that's the title of the session will be. It took 3 hours to evolve this to Omega.
Yeah, like quote unquote evolve, right? We
Oh
have
man,
so fucking much flaws
the
and
thumbnail should be a transformer, man. Please, like this or a Gundam mecha or something like this.
wait, what? Oh,
No,
the
like
Omega name, right?
Anyway, Nathan, can you help me with the E-type abstraction here? So I noticed something kind of wild, right? Which is the
Why?
fact that you have kind information in your E-type abstraction. Is that correct?
Uh-huh. Why is that?
That is because you want to know what is the kind of the body, I guess.
No.
No.
What is the argument of type abstraction?
E-type abstraction, you mean?
Yeah, is type abstraction.
In our implementation, we only have the name and the body.
No, that's not what I asked. What is the argument that eventually E-type abstraction will receive?
A type.
A type, right? So I need to check if the type that I'm getting as argument, it's the same I'm specifying in my parameter, right? So that's why I need the parameter kind.
Wait, can you repeat the last part?
Yeah, I'm receiving a type as an argument. So my parameter kind will put a constraint in which type I'm receiving, right?
Yes.
So that's it.
No, but so we do need to add this to the AST.
Yes, I think we forgot, right?
We totally forgot. Ah, okay, so types.
Lemos will
My
is doing
mind,
well
my
today, man.
mind. Ah,
Oh, Fryman.
wait, is this the only expression that interacts with kinds directly like this?
Uh, Can you do the following? Can you see where the name type is being used inside the data expression?
Where the word type?
Yeah, just put like your cursor on type, right? And then we can see like why it's not highlighting the other places.
Because this is not VS Code.
But you were just doing that, like
No, I was doing like this.
yeah, this, yes, this. I want this, but with type. Okay, so you see that we only have in uh,
Do we? Wait, I'm confused right now because if an E-type abstraction needs to receive a kind, that means that when I'm writing the E-type
no,
abstraction,
not to receive,
no,
to
sorry,
have, right?
yeah. So what is asking for, right? Does that mean that I'm gonna have to write that down when I'm writing a program?
Yes, of course.
Do you like that, Magetta?
Wait, what? I wasn't paying attention.
You're writing your Silverware plus code, and then you're
Mm-hmm.
writing a E-type abstraction.
Mm-hmm.
Nathan, in the way that Nathan did it, you need to specify the kind of which the label needs to be.
Okay.
Do you want to make that optional or not?
How would that look like? That's my
What do you mean
problem.
by optional? we
That
Yeah.
cannot
would
dis we cannot disable it unless we opt for not having higher kind of types. Because then you assume that they are only star.
oh,
And I have something worse for you. Take a look on the type
Oh, I see.
of abstraction.
on the type of abstraction.
T
Where?
abstraction.
E abstraction, you mean here.
No, T abstraction.
Oh, T abstraction. Here.
Yeah, you see that you have a kind here there?
Yeah.
So you see a problem with that? On the syntax, you have to describe the kind of
Oof.
your
Oof.
By the
Ouch.
way, I think something's possible. I think something's possible there, but I have not completely sure. But I was thinking about that. So, uh, you guys agree that type declaration for like ADTs and records are different from type alias?
Wait, can you repeat that last part?
Do you agree that me declaring a new type like a record or a ADT, it's
Yeah.
something different from a type alias?
Oh, yes.
One in the ways that they are different is that the type, well, they are all, how can I say, they can all be T abstraction, right? If they are receiving parameters and such, right? Um, but that's the thing. Uh, when I'm declaring a type like a record or ADT, it will have a type on the right side of the equal, right?
Yes.
And it is a type that describes a term, right?
Okay.
Uh, yes, I guess.
Like a record, like it's the type, it's a record or a ADT. They describe terms, right?
Yes.
So they always have to be star, right?
Yes.
But with type alias, that's not the case, right? A type alias could return something that is not kind star.
That's correct also.
Yeah.
Knowing that difference, we could at least on declaring records and ADTs assume that the output is kind star.
That
What does
makes sense.
what does that give us? Every like in the case of record, every the type of every field also needs to be a star, right? Why? Like the kind of its
Ooh, but
types.
that sucks, right?
No, that doesn't.
Well, but what if I want to have a type operator inside the record as a field?
Well, it doesn't make sense because records store values, right? Not types. I
Records
cannot, I can, I
store.
cannot, I cannot have a record with a value of maybe because there are no values for maybe.
People, give me 5 minutes, please. I told you
Okay.
today is a messy day here. Holy fuck.
So Mageta,
Wait, just
so
a second. At the yes. Okay, I'm looking.
so wait, let me just answer some message.
Okay.
Otherwise,
I'm making a thumbnail, by the way, for the Lambda Cube
oh, it's the
competition.
Gundam here.
No, no, it's much better. You just need the Lambda now.
Okay, so when you finish there, you say.
Yeah, just second. Here. Oh, this is bad.
Okay, I'm back.
Um,
Okay, so I left when we were talking about if it makes sense or doesn't make sense to have a type operator inside um,
of the types of a field of a record, right?
of a field of a record. Yes.
So the record it store values, right?
Um, I think we are getting pretty close to the territory of type families, and I don't know
No,
how
no, no, no,
exactly.
no, no, man, no, no. No.
No, we are.
When
We
it,
start asking. I'm starting asking. Does is it useful to have something like a group, something that I can group multiple type things instead of values?
yeah, that could be a module, right? A module have values and types inside, but that's not what we're talking about.
Yeah, but as far as maybe I'm completely wrong, but I do think that this is related to type families. But okay,
Well, I don't know, but let's make it simple. When you are constructing a record, you are passing only expressions to it, right?
so it's everything star.
So every type in the fields of a record needs to be star, right?
Hmm.
So okay, we know that the result is star, its components are also star, right? I guess we could use that fact to do kind inference on the type values I'm receiving,
That makes sense.
right? So yeah,
That makes sense.
so I could not do, I guess, yeah, I'm pretty sure we could not do kind inference on type alias because type alias can return anything.
Yeah, yeah, yeah,
But
yeah,
when
yeah.
declaring records and entities,
Yeah, but
Literally, yes.
then we can just not obligate when doing ADTs and records to tell me the kind because
yeah,
every
so see, kind reconstruct. I literally doing the same thing as the thumbnail that Mageta is doing.
Literally is right
Yeah,
now.
I'm literally doing the same thing right now.
wait, I'm not getting the meme. Why?
Uh,
Look at the chat.
Yeah, yeah, I'm seeing the guy is having a hard time.
No,
that's
no, no.
Professor Xavier from the X-Men.
Yeah,
Yeah.
okay. I'm not
The
a.
dude
No,
with
but
like
I'm not saying that I'm feeling the same. I'm saying I'm literally doing the same pose, like something that happens sometimes. Uh, yeah, when you are explaining something, sometimes you do that, right?
Yeah.
Uh, so yeah, we will have funky kind inference when doing your record and entities, man. How
oh,
awesome is that?
oh no.
Oh my god.
So
Okay.
instead of type reconstruction, will be kind reconstruction. So
Okay.
that's fire.
Let's go back to normal stuff.
No, no, wait. One more thing, dude.
Okay.
Uh,
Go.
you see how Haskell names its types and its type variables. Well, not its types, but well, also its types, but its type aliases and its type variables in the same casing,
Type
like they,
aliases and type verbs. Yes.
right? So when you annotate something, how do you know if it's a type alias or a type variable? How does the parser know?
A good question. Like, unless it's like Pascal and there is no difference.
Wait, the question is how the
Maqueta,
compiler
Maqueta point, it's a good idea.
how the compiler knows how to differentiate a type variable from a type alias.
Yeah, the
Yeah,
parser more
that's a good
specifically.
point. That's a good point. And I think in Okama you cannot make a type with a uppercase letter, right?
Not only that,
Wait,
they
wait,
all
wait.
start with
But
quote first.
didn't the doesn't the only way to add a type variable? Oh, but in Haskell you don't actually have to do for all to have a type variable. In our case, we are limiting
I mean,
ourselves
I
to
mean,
have, but
but man, don't think about the expression. Think about the types, for example, right? So when you are writing a type, then you write a type variable explicitly, right?
your question
So
is how does it know when you're writing like you are writing the thing?
well, do the following. Write the type for lists there. You don't need the empty case.
Well, it's gonna be something like data list a uh,
Wait,
list.
what? Wait, is it uppercase A?
No, isn't. It isn't.
Oh, so I'm just wrong. Like that thing doesn't apply.
No, but when you're doing for all in the type signature, for you do with
No,
the all
no,
capital stuff.
no. Yeah, but the thing is, I was thinking that you use also uppercase on. Well, let's use uppercase just for the point of discussion.
Okay.
So do the definition there of the cons case, for example.
Yeah, and then it's gonna be cons a list no a and then list a.
Yeah, if you were to have that syntax, right? How do you know that A is a type variable and not a type alias? It's not referring a predefined type, so type alias, right?
You
How do
could
we
have some
know
sort
that?
of priority though. Like
What does that mean?
you pick the thing that that can be both, and then you look at the environment, and if this is
You
type
don't have
alias.
environment. You are the parser,
Yeah,
dude.
that point. Yeah.
No, you do have environment if you have a two round parser.
No, that's just bullshit, man.
What?
You don't want that.
No, I don't know. I don't know if I agree with that. That doesn't make sense for
First
me.
of all, that I'm not completely sure what you mean because even if you are like doing two passes, you don't have a. Oh, okay, I see. You construct some quote unquote
Yeah,
environment,
of
right? On
course.
the I see. Yeah, but that's just really bad, of course. You don't want two passes on a parser.
No, sometimes you have to. We don't.
Okay. Sometimes you have to, but you
Yeah.
don't want. That's not desirable.
No. You can desire whatever. The fact is, in a scenario where you are already using a two-pass parser for some other must-have reason, you could do the first. You could add this priority system that I'm talking about to the first pass. So you're gonna this can be a type variable or type alias. You consult the environment, and if it already exists, then you assume it is a type alias.
So you agree that that's really complex.
Yes.
So therefore, it's bad, right?
Yeah.
So how do you do without that? I think
Uh,
I got away, man.
okay, let's not talk about it because it is already getting too out of the way. Let's just finish type checking this madness.
Wait. It's easy to explain. Like you will parse everything as a type alias, right? And when you are doing something like putting things on the context, right? When you are like checking the type of the body, and then you need the how can I say? You need, for example, the kind of a type variable and such, right? Instead of introducing something with the type variable, right? You introduce like also a type alias pointing a name to that type variable, right? So
That's kind of hacky though. But yeah,
what do you mean by hacking?
you're kind of
It's so
redirecting
much.
stuff, man.
It's so
There.
fucking better than that.
The
I mean,
event
I
is
think,
created, by the way.
huh?
I want to see the
Oh,
date later because
And
let
I think you
it's
can do the
yeah. We can
same.
change. Okay, I'll just let them
go
finish.
Nathan.
I think you can do the same with data constructors and putting them into the environment of values. so they can be functions like they are in Haskell and F sharp and not in Okama.
Yeah, and I got lost in that in the final part of that.
Yeah, we can discuss that in a month or so.
Okay, so as far as I can tell, we now have a kind in here. So we're gonna just add that to our stuff. So it's gonna be map.insert kind and then kind context, right? So this is gonna be kind
Man, it would be so
context.
funny if Victor joined this thing and
There's
he
no
made
way.
this in Go. Like this would be so funny.
It
Oh,
would be
shit.
very boilerplated, like.
I would say he had balls, man, like huge balls. Because holy man, that would be hard. It's not C hard, but
Well, the
pretty
challenge is
hard.
set. If he wants to prove that he's a man, he needs to do.
Not a man, like the man.
No, but here's what I'm thinking. Oh, okay, let's discuss it later. Like we're still recording, right?
Yeah, I'm still recording. I want to understand how we're gonna type check the. Wait. Oh no. Oh, wait, I'm saying wrong things. So this is the new kind env, and then you're just gonna do kind context is equal to this new kind env, passing the body to type check it. Oh my fucking god. This will return a type, and then you do the same, but you pass the kind. So because and T4O info also has the kind also, which is great. Okay, so projectile save all
Okay.
buffers.
What is the next one?
I have no idea. We're gonna discover right now.
Let's see.
Okay.
E
So
type
E type of oh, it's the
abstraction.
evaluator. The evaluator is now broken.
Oh, okay, yes.
E type.
Yeah, just ignore it.
Yeah.
Kind you
Okay.
cannot
So now it's
import.
complaining.
Types
We
does
have
not
a par.
define
Oh, the
kind.
parser. Oh no.
Oh, but no, screw the parser. Screw that garbage. No,
Now that the data type is different, the parser is saying, "Hey, you
okay.
gotta update me also, buddy."
Kill me.
Holy crap!
Can you just unlink the parser? Oh no, man. Stop.
Oh my god.
This is torture, man. This is torture. Oh, thank you.
Okay. Okay.
Okay.
So now we need to import and
Module
export
types
kinds.
does not export kind. Okay.
So,
Back.
There. Yeah. Okay.
the T variable, T application, T abstraction, the same problem as always. This is
Wait,
happening in the
which?
typer, right? Yeah, I know the problem. The problem is that we need to import all of those scraps.
Oh, okay.
So now we have a T variable, or yeah, we have a T variable, we have a T application, and we have a T abstraction.
Abstraction.
We are forgetting a peer somewhere on the kind check.
Oh yeah, that's true.
Wait, what? Oh, kind check.
Set empty.
Map.
What? No, but no, wait. You still need the second guy right there
No, we do have both. Two maps.
on the map.
Yeah, I have two
No,
maps
no,
now.
but no, on the map you just added. That
On the
just
map we
okay.
just
That's
added.
just empty.
Yeah.
Never mind.
81. Meta. What is meta GG?
Yeah, to go to line. Yes.
Oops.
Dog.
Meta
I'm
dog. Meta. Yeah. Okay.
81. Wait, what? What the
Did
heck are you
I'm
talking about?
gonna.
It's ta
Yeah.
it's talking
Kind.
81, line 81 specifically. So this
Yes.
that doesn't
Oh,
make any
kind check. Yeah, kind check receives. What is type?
Oh, oh, we are dumb.
Oh, wait.
Okay, so expected kind this.
Oh, okay.
Wait, what is the problem there?
Yeah, it's like it returns another crap, right? Wrapped.
Yeah, exactly.
Oh,
Yeah, Magetta is getting the gem of it. Ah!
Okay.
Oh,
Now what
it
is
gives you
that?
a warning about this crap behavior. Awesome.
Shadows the existing. Okay. I don't
Okay.
know about crap behavior, but yes. Okay.
yeah.
Okay. It compiles.
They have a bunch of warnings. I love it. Okay, like
Now
stuff we're
you
not
can
using,
remove
right?
the data. We can remove this guy.
Yeah, set. What's the other one?
We're not
Why
gonna
we
get. We
know?
can add this flag to
I
the.
just rename it. Who cares?
So typer 100.
Did you already saw the idiom of you doing a where on the last thing as the function and call it like rec, and then it's just a successive call to the same thing already passing some arguments? Like you see that inside of kind checking, we are calling kind checking a bunch of times, right? And passing the env again. I saw idiom that people do in Haskell that is calling that rec and putting in a where as the last thing of the function.
Uh,
Is that maybe right?
okay, so let me present to you guys the maybe function, right?
Okay.
So this is a function that is pretty useful. I used these in the either one are awesome because here's the signature of it. So what do? You provide a case if it fails, right?
Mm-hmm.
You provide a transformation.
That's just the default.
Yes, that's what I was going to
That's
say.
just the default, dude.
Wait, what do you
That's
mean?
literally result.default
Oh, you're
or
talking about
option
that sharp,
default.
right?
Yeah.
We also have the either one like this, and these functions are pretty useful.
It's the default, but I'm also doing mapping, right?
Yeah, specifically when you add the error case as null there in F sharp. That's lovely. I love
Oh
it. I deal
no,
with that every day. Yeah,
that
that's
doesn't
awesome.
sound good.
Did I save this? Yes. Okay. Next one. We have
Career arrow.
parsing warnings.
Yeah, but warnings are not errors, right? So you can
No,
just
no,
ignore
it
them.
is still just warnings. Nothing too fancy.
Words are not there.
But we
That's
can
a
stop
good way to
recording,
think about
guys.
it.
That's a good way.
Oh, Victor replied, going to prepare my efer macro.
Well, I think that we are done for today.
Yeah. So let's discuss about the marathon. Let me express the
No,
ideas.
wait. Let me finish the recording now because 3
Okay.
hours and 7 minutes.